according to your religion. Go
Okay.
ahead.
Hey, no,
solid.
moving it upward. No, I'm
You
not.
can't
I'm not
do it.
doing this, dude. I'm not
You
doing this
can't
with you.
show me that.
No,
You
I'm
cannot
not.
show
I'm
me that.
not
You
doing it
just
with you
believe
because
it. This is
yeah,
why
no, I
you're in a
can't. I
religion.
can't show you
You're
something
in
that
a
doesn't
religion.
exist as possible.
This is
No,
why
I'm not in a
you are in a.
religion.
You
No, I'm
believe it's
not.
attracting the earth. You believe it's attracting the earth upwards. You believe that. You believe
No,
that
I
the
don't.
gas
I
has
don't
mass.
believe it's attracting the earth upwards. No, I don't.
Yes.
No, I
The
do
mass
not.
does not attract
No,
mass.
I
Then
don't. Don't tell
admit
me
mass
what I
does not
believe.
attract
I
mass.
don't believe that. I don't
Then
believe
admit
that. I
that
don't
mass
believe
does
that.
not attract mass. Then admit the gas has mass, which is not attracting the earth upwards. Admit it. But you can't do it because you're in a religion.
There's
And you
no,
can't
no, no.
prove it either.
Yeah, no, I'll admit that. There's nothing that is attracting the earth upwards. Nothing.
Okay, then mass does not attract
yeah.
mass. Then mass does not attract mass. Because the gas is above the earth, and the gas has mass. The gas is above the earth, the gas has mass, the earth has mass. And you just admitted. So mass does not attract mass. Thank you.
The gas is also below the earth. So when we have
show me it
equal,
moving it downward then. Show me
equal
moving
things
downward.
above and below, we
Show me
just kind of
show
end
me
up
the
in
gas
space,
moving.
right?
Okay, show me the gas mass attracting the earth downwards. Go ahead. Show me it moving the earth downwards using mass attracting mass. Go ahead.
Well, that would require you believing that the earth is a sphere, which you don't. So
You can't even do it if I did. Even if I did believe it,
if you did, then the gas is pulling the earth in all of the directions, both upwards and downwards,
Prove it.
and outwards and inwards.
Prove it.
And then
prove it. Prove what you just said right now. Prove what you just said right now.
I can, but I can't with your.
You can't show me the earth being attracted by gas. Why? Because the
earth could be attracted upwards and downwards by the earth at the same time.
How would you know if you never tested it? How would you know?
Have you ever tested it?
I'm asking you. This is you. This is your claim. You're the one claiming it. I'm not saying I believe it. You're the one saying that gas mass attracts.
I don't believe it, nor did I claim it. I'm just saying that you don't know either that it's only going upwards. Okay, how do you know that it's only going upwards? Wait, hold on. How do you know that it's only? Hold on. No. Hey, don't switch it around. How do you know that it's only going upwards? How do you know?
I never said it wasn't. I'm just asking you. How do you know that gas, which has mass, is pulling and attracting the earth, which has mass, toward the gas? How do you know that?
Well, because we have micro experiments where we use gas and it does attract other gases, correct?
So can you show me the earth being pulled towards the gas? Can you show me the earth being pulled towards the gas?
Well, the earth is really massive and it's not made of gas.
So you can't.
It's solid.
So you can't do
that. No, hold on. Yeah, no. We don't have like measurable ways that the earth is pulled towards the gas that is in our atmosphere.
You just
but the atmosphere of our earth is pulling forces on all of the earth in multiple directions, not just one direction, right?
Do you believe
you have an idea that's only pulling in one direction? How would I possibly prove your misconceived idea? I can't.
Because
I can't even disprove
you just believe it. You just believe that the
gas
is attracting the earth towards the gas.
No, sir.
Mass does not attract mass. Then mass does not attract mass. Mass does not attract mass. You admitted it. You just admitted mass does not attract mass.
No, sir. I would disagree with you on that. But what you just described as an example
you just said it. You
just
said it doesn't attract.
Sir, I need you to listen. What you just described as an example is not an example of that.
So show me the gas which has mass that you believe. You believe that gas has mass. So show me Earth, which has mass, which you believe has mass.
Yes.
That is being pulled toward the gas, according to your belief, that mass attracts mass, because gas has mass and the Earth has mass. So show me the gas pulling the Earth towards the gas. Go.
Sun, Earth orbit. Good.
Okay, so you believe the Earth? You believe the sun is made of gas, then?
Mostly, yeah.
Okay, prove that. Prove that the sun is made of gas. Go ahead. Prove the sun is made of gas. Go ahead. Show me how you measure that. Go ahead.
How I measured the sun is made of gas?
To prove it. You don't have proof, do you? Show me the proof. Did you prove that the sun is made of gas? Or yes or no? Simple question. Yes or no? Did you prove that sun is made of gas? Go ahead.
No, I don't.
And you believe it. Then you're in a religion. You just believe it. You don't have proof. You just have stories.
Okay. And you're in a religion too. And I disagree with your religion. And I think your religion is stupid.
What is it? What's my religion? Go ahead.
The one that believes that the sun isn't made of gas, which is stupid and retarded.
I never claimed it wasn't. I'm asking you to prove it. I never said it wasn't. I'm just looking.
I'm not fucking. I have the burden of proof, and I said I don't have it.
Okay.
I don't have it. I don't have the proof.
In my view,
your belief system, your contrary belief system is actually stupider than mine, even though I have no belief.
There's no belief.
The dumbest possible thing.
There's no belief. The sun is just the light I see in the sky. That's all I know. I just see light in the sky. Perfect. That's it. There's no belief. There's no assumptions. There's no beliefs. No assumptions, no beliefs right there. No religion. So again, how am I in a religion? Go ahead.
No, okay. I want to listen to you. Go for it.
You're the one who said I was. So go. Tell me how I'm in a religion. You said it. Go ahead. Try again. Try harder this time. Try harder.
Oh, okay.
You failed the first time. Try again.
No, it's okay, man. You're right. You win. You're the best.
If you admit, and by the way, just so you know, if you ever do find proof that the sun is made of gas, let me know. Also, if you ever find proof that the gas, which has mass, attracts the earth and pulls it towards the gas, let me know. I'm open. I'm open to the proof. All right.
First of all, gas having mass is nothing compared to the mass of the things that are happening, right? We're describing things that are happening, right? The earth orbits around the sun. Do you agree or disagree?
How do you know that? How do you know the sun?
How do I know that? I mean, there's a lot of observations that can prove that. Do you not believe that?
The sun is moving. Don't we agree? The sun is moving. That's all. All I see is the sun.
Yeah, in relation to us, yeah, we all agree that the sun is moving, but most of us believe that the earth is moving in relation to the sun. So imagine this. Okay, let's start at the very beginning. If you're standing on a street and a car moves by you, how do you know that you're not moving and that the car is moving? How do you know?
I don't know. I just assume.
Oh, you don't know. You just assume. Okay. So how do you know that you're correct here? That the earth is moving, the sun isn't moving. How do you know?
I just see a light in the sky. That's all I know. I just see a light in the sky.
Well, you just see a car moving past you. How do you know that you're not moving and the car is moving? How do you know?
I just told you. I said I don't know.
Okay, so you don't know what is movement. You don't know what is moving, what's not. So if you're standing still, you don't think that someone like throwing something by your head, you don't think that that's moving. You think maybe I'm moving, and that thing is standing still. Is that how you conceptualize the world?
If I'm in a car and I'm driving.
No, imagine no. Don't even be in a car. No car. You're standing in your apartment. Someone throws a ball by your head, and it just goes right.
I assume the ball is moving
really fucking fast. And you assume that you're moving and that it's not moving, or do you assume that you're not moving and that it is moving?
I assume the ball is moving. Yeah, I assume.
Okay, why? Why do you assume? Why do you assume that? No. Why do you assume that? Okay,
because I see it. I use my eyes. I just see it. I use my senses. That's it.
Well, how do you know? How do you know that you're not? And that
how do you know my senses are not lying to me?
Yeah, sure.
I don't. I just assume they're not lying to me.
Okay. Great. Good answer. Okay. So now you're standing on a street, and a car goes by you. How do you know that you're not moving and the car is?
When I'm standing on the street and the car goes by me, I just use my eyes. I just use my senses. I don't know.
Right. But you're not really sure that you're not moving.
I'm just assuming when I look at the car
you're just moving, assuming. Right. Yeah, I'm perfect. Okay. So now when the sun goes up and down, how do you know that the sun is moving and that you're not moving?
I'm assuming that as well.
Okay, cool. Yeah. So you're basically saying that you don't know anything that happens in your life is real or not real, or true or not true. You have no idea. You're just experiencing things, and then you're coming to me telling me that I'm wrong about my understanding of things.
Well, if
and you have no idea, you have no idea. You're
if
saying
you had the evidence, no you wouldn't need to. If you had the evidence, you wouldn't even need to.
Well, the evidence, like you, sir. Of course, the evidence would be personal, right? It'd be anecdotal. I see the sun rise. I see the sun set.
But you don't see the Earth going around the sun. You don't see the Earth going around.
Yeah, but I also have other people that I can go. Hey, did you see the sun rise over there? Yeah. Okay. Did you see the sun set over there? Yeah.
None of those people saw the Earth go around the sun.
Nope.
You need to see. You need to actually see the Earth go around the sun. But you're claiming that the Earth is going around the sun. So who saw that and where?
I'm claiming based on observational evidence, and you're claiming nobody
saw the Earth going around.
I don't know.
You don't have any observations.
I agree with that, but
you don't have.
We have a lot of we have a ton of observational evidence. If the sun isn't with me, the sun went around. Sun is gone from my point of view, and I call someone in China, and they go, "Yeah, the sun's coming up."
That's not observing the Earth going around the sun.
Well, that's observing. That's observing that the sun is coming up on another side of the Earth, right?
It's what do you mean side? Side? What do you mean?
I don't know. What do I mean?
When you say side, just say, instead of saying side, just say, I observed the sun appear and disappear from my field of view. You can say that. I agree with you there. But
sure. I observed the sun appear and disappear from my field of view, and then with time zones, I can call people in other time zones, and they can observe the sun appearing at the same time that I would expect it to appear. I would expect it to appear with a globe model, with a round Earth model, and then I would expect it to disappear at the same time that it disappears from their view with a round Earth model.
You don't need a model to prove. Listen.
No, there's actually a model that does. It's not a model that proves anything.
Can you just listen?
Sure, no. It's not a model that proves anything. It's a model that describes something.
Why can't you just look at the Earth going around the sun instead of having to rely on an imaginary model? You don't even. First of all, you don't even need a model to prove something. Okay, so if you just look and see the Earth going around the sun, I don't need any kind of bullshit model to prove that is the truth. Okay,
so if you actually wrong. Saw that, you need a model to prove something.
You don't need
proof. There's no proof that exists in the universe. In the universe of both my mind and your mind, that does not have a model associated with it. You do need a model to prove something. So you are wrong about that, sir.
So I'm sorry that you're wrong. You need a model to know you exist.
Yes.
Okay. So do you think that someone who doesn't exist?
Sir, I'm not going to do presuppositional bullshit with you when you can't even admit that you are wrong about this.
You don't need a model. I'm illustrating to you why you don't need one. You're just interrupting me. Okay, so you just said that in order for you to know that you exist, you need a model to prove it. And I'm asking you a question to challenge that. What I'm saying is, do you think a person who does not exist could deny verbally their own existence?
No.
Okay, so can you deny your own existence right now? Can you say I do not exist?
No.
That would be really weird, right? Don't you think? The law of identity?
No.
The law of identity is a model, right?
I don't think it would be really weird. Why do you think it'd be really weird? What's up?
So if something that doesn't exist, denying its own existence would not be weird to you?
Wait, no. When did I say that? And why do you think I said that?
You said no. It wouldn't do that. Obviously.
No, I said it. I said it would be. Wait. Hold on. I said I think it would be weird if something that was existing denied its own existence, and then you turned it into whatever the fuck that you think you're trying to get into.
The opposite also is weird as well. Yes, yeah, both scenarios.
A non-existent thing would be kind of weird to say that it is non-existent because it doesn't exist. Yeah, that would be kind of weird.
Yeah, so both are weird. Yeah.
Okay.
So the argument I'm making to you is that you exist because it would be the level of absurdity. In other words,
sir, the argument that you're making to me is like some ontological argument that isn't landing. First of all, because
it would be absurd if you were not existing and able to deny your own existence. That would be absurd. So obviously, you exist.
Okay.
That's not even my argument.
I don't know why we're doing the empirical ontological conversation right now.
Because I don't know why we're doing this to prove something. You don't need a model.
Yes, you do. Yes.
Okay.
You do.
Okay. So if I show you a car moving, does that prove the car moving?
What is your model for? Wait, hold on. Let me just ask you this very simple question. What is your model for non-existence? What is the model for non-existence?
I don't have one. I don't have a model.
Okay, cool. So you don't need it.
You mean like definitions? You could argue that definitions are models. Sure, maybe. I might even agree with you there, but I don't know about a model.
God damn, dude. I don't know what you're doing or why. I'm just like I don't know. I'm such a pragmatist that like maybe I'm just like
if you saw a car
missing all these fucking horrible things that you're doing, but I'm a pragmatist. I care about what we care about and what we do and what we are.
If you saw a car moving, you don't need a model to see it's moving. It's proof. You can look at it. At the very least,
correct.
You can see
that's correct moving. As long as you acknowledge that it is moving and you are not. But if you think about relativity, you could be moving and it is not. And how do you know the difference between you moving and it moving?
Right.
How do you know?
I get what you mean. Okay, let's make it more general then. Okay, let's just say
no. I don't want to make it more general. I want to make it just that specific. Let's just do that. Let's do that conversation right now.
You can prove that something is moving without a model, either the car or you. You could say in general. You don't have to claim it's the car or you. One of you is moving. You could say either I or the
something car is moving. There's something moving,
and you don't need a model to know that. You don't need a model.
Well, we need a model to understand how we interact with the thing that's moving. That's the model. That's the point of the model. But you don't
need a model to prove that either one of you, like basically the claim.
Yes. No. You are correct. When you look at a car moving or a train moving or anything moving, you go, "Wow, that thing is moving," and I'm not moving compared to me because I'm me, and I'm here right now. And then there's something going past me, and that's obviously something moving. Yes, of course. Do you not think that we all agree on that? Like, of course we all agree on that.
So we agree that something is moving, and you don't need a model to prove it.
Well, no, the model is the thing that's important, but we all agree that something is moving. Are you moving? If you're on a train and you see someone and they're like flying by, you're flying by that person, would you say you're moving or that person is moving?
One more time, say again. One more time.
If you're on a train, you're looking out the window and you see someone and they fly past you, are they moving or are you moving?
If they fly past me and I'm on a train,
you're looking out the window and you just see a person and he's like at one point in the window and then he's at the other point in the window and he's gone. He's gone going down.
I would assume the train is moving. Yeah. I would assume.
Okay. Yeah. Okay, cool. So you're moving.
But that's
now if you're the person, you're looking at a train and you're looking at the person on the train, would you say they're moving or you're moving?
And my assumption is that they are moving. Yeah.
Great.
From what I can see.
Okay.
Yeah.
So then we create models based on that. Just that. Just those assumptions.
You don't need it, but to see to notice that. Let me be specific, okay? The claim is that either just listen. Holy fuck, bro. The claim is that something, whether it's me or the train, is moving. In order to prove that, I don't need a model. I can just go outside and I see either the train is moving and I say, oh, okay, so it's either me or the train. At least something is moving. That you can prove, and you don't need a model at all. So yes, you can prove something without model. You don't need a model at all. You don't need a model at all to prove that.
Okay, listen to me just
for a second. You can go outside and do that yourself. You don't need a model at all.
Okay, listen to me just for a second. You've just put yourself as an observer outside of the person on the train and the person outside of the train. And you've said, we don't need a model. We do need a model because either you are the person on the train or you're the person outside the train. Yes.
You do need a model.
Nope.
Yes, you do.
Nope. Okay, so when you go outside, when you open your door and you look outside and you see a bird flying, do you need a model to see it flying?
Nope.
You need a model to understand the motion that you have compared to the bird.
It's a yes or no question. It's a yes or no question. Do you need a model to see a bird flying in the sky when you go outside? Yes or no?
Yes. Nope. Yes.
You're a fucking liar.
It's not. First of all, it's not a yes or no question, and second of all, yeah, bro, no, you guys are fundamentally misunderstanding what these models do.
No.
These models aren't describing what's happening. These models aren't making you more knowledgeable about what's happening to you. These models are just.
You guys want to take into account that this guy lives in a sideways house. He said earlier that his house is not horizontal; it's not in level. And also that he believes that red rubber balls prove gravity. So yeah, you just gotta take that into account. Go ahead, CW.
Gravity enough for some of your ilk, you fucking idiots. But I mean, come on. I mean,
you can't prove gravity.
I asked this guy about the level of the property he's standing on. He said, "No, it's not level."
Well, let me just say.
So when he pulls out his rubber ball from the box that he said, the container he said he had it at, he says that the ball rolls down the hill. His house.
Can do this a little bit better. Maybe you can do this a little bit better. I've been trying to do this. I've been trying to.
He's trying to say something. So
I want to say something quickly. I'll be quick. Go ahead, like, bro, he just has everyone muted. He's just monologuing. I don't understand what's happening.
I get more doubt. What the fuck? That's crazy. I was about to leave anyway.
He's a liar.
WLD is hot miking. Thank you. Okay, I don't even know if CW's listening, but for the audience, because we don't appeal to the council for the globe, we're appealing to the jury. So for those listening, we don't need a Hot Wheels of the Earth. These are representations of the real thing. You go to your grandma's house and she makes you dinner. Do you need a representation of the experience you're having? No, you don't. You don't need a menu. You don't need a menu to represent the meal, right? The map is not the terrain. The menu is not the meal. The model is not the Earth. We don't give a fuck about your little Hot Wheels version of the Earth. First of all, you don't even have one of those for your worldview. So let's just rip that Band-Aid off. You don't have a model to represent your worldview, period.
Yes, you're absolutely right. It doesn't matter. When you go to your grandma's for house and she makes you dinner, you're not like, hey, what model
of but I need a model, ma'am.
My dinner.
I need a model for that, ma'am. Please.
No, you don't have that. You eat the dinner and you're appreciative of it and you love your grandma, and that's fucking awesome. There's no reason.
No, I'm not eating it unless
I totally agree with you.
So why'd you say
no reason to bring this into consideration?
No, we need a menu or we're not eating.
No, I was never saying that. I need a model, never would say that.
You have to have a model.
I never will say that.
But you said you needed it to prove it.
You said that you need it for a bird in the sky. What the fuck?
No, I don't think you need it for a bird in the sky. I think that in order for you to have a coherent philosophy where it comes to what is reality, you do need to understand. Hold on.
I get what you're saying. We're not trying to present a philosophy.
I know, and that's why I'm saying that it's okay that you eat grandma's food. But in order to have a coherent philosophical point of view here, you need to understand what the birds in the sky are. If you're saying, hey, do I need to have a coherent point of view in order to eat my grandma's dinner? The answer is no. You eat your grandma's dinner, you love it, and you fucking enjoy having spent time with your family. Of course. Yeah.
Just like the bird in the sky, you're like, wow, that's beautiful. Just like the earth, wow, amazing.
Yeah,
flat.
I'm such a pragmatist that like these conversations like put me in this pigeonhole that you guys are like, oh, you think that everyone should be suffering until they die. No, I think everyone should be enjoying their lives until they die as much as possible. There's no way that you guys are gonna put me in that.
CW, can you control yourself a little bit?
Hey, no. So we have a philosophy. It's called direct realism.
Sure.
Yeah, so there's a bird in the sky. That's what it is.
Yeah, well, your direct realism is fucking stupid because your realism includes
your realism. Your realism. I don't know how I'm going to recover from that.
W, can you relax a little bit?
Your realism includes
I'm gonna have to start muting you
that you can.
Okay, W. Wait until other people are done and then reply. Okay. Don't speak on top of other ones because I'm trying to listen. I don't want to hear that. Okay, go ahead.
So, would you ask for a flat Earth model?
No, bruh. Yeah, you just show up in the middle and then you go, okay, well, I'm here. I know. No, the answer is.
He said he needed a model to prove something, and I'm telling him, no, you don't.
No, you don't.
Yes, you do.
No.
Okay, give us a logical statement about why you need a model to prove something.
A syllogism is what you were about to say.
Yeah, I was, but I'll settle for something less than a syllogism. I would just like a lot.
Yeah, no, that's fair. If something is logically proven, then it has a syllogism associated with it. If someone says something that has no syllogism associated with it, it's not logically proven. Therefore, people that are saying things with no syllogism associated with them are not logically proven, nor are they syllogism.
Thanks, Captain Obvious. Can you make a logical statement, any type of logical statement, inferential, reductive, abductive, deductive, that you need a model to prove something?
Yeah, so models are necessary to understand the world.
Stop the cap.
Do models
we just walked you through 2 examples where you don't need a model, a bird and your grandma.
Crazy. Do models explain things?
Yeah, absolutely they do. Yeah.
No, incorrect. Models describe things.
I agree with that, but they also explain them.
How can they possibly explain them when they are a model of something? They don't explain.
If you have anything. A syllogistically proven model, then it explains the thing that you're thinking about. Yeah, absolutely.
Can you give me an example of a model that has explanations?
Let me think about this. Hold on.
Thinking for infinity, dude.
Yeah. Okay. All ideas have thoughts behind them. Ideas are the product of the mind, therefore all thoughts are a product of the mind.
So that's a model. What's that a model of?
No, that's a syllogism. That's actually that's a logically consistent syllogism that explains that models do not have explanatory power. and never have. Models do not have explanatory power. They never have.
Thanks. That's what I just said.
No, I know. Yeah.
Okay, so what's
a contrarian? Is that your issue?
I'm not a contrarian. The guys that were saying models have to be there in order for us to think anything are wrong. You can have an idea that's not a part of a model, and you could be wrong about it. That's totally within the realm of models. And you can also have an idea that's right.
Well, let me break down how models work.
You could also be wrong about that idea without a model. Go ahead.
Break down how models work in science, right? Models in science describe phenomena, right? So if you drop something, how it falls, you have a model for that, right? So we got the little G equation.
We were trying that. Didn't work.
Yeah, so it's a model. It's a descriptive model of how something falls, right? But that's a phenomenon. This is flat Earth. Flat Earth is not a phenomenon. Now, if you want to model a particular phenomenon, what model?
Flat Earth is a phenomenon, is it not?
No, a phenomenon is like a verb.
Flat Earth.
Keep doing this in this channel, like verbs and nouns, man. Like you guys don't know the difference in verbs and nouns.
First of all, flat Earth is not a verb.
I know that. That's what I just said. It's a noun. Phenomenon, though, are verbs. They're actions. They're things that happen. So there's natural phenomenon, and that's what models do. They describe natural phenomenon, typically.
Right, and the natural phenomenon, if you look at any of the studies that have been done on natural phenomenon, we find out that the Earth is definitely not flat, right?
Okay. Which phenomenon?
What?
Which phenomenon shows the geometry of the Earth?
The parabola of throwing a ball.
What?
Thank you for that.
Fucking Christ. Oh,
wait, what? Ain't no way. You just said that.
You know it's against TOS to do drugs.
Yeah, don't do
drugs. Why are you guys so like laughing?
How does the parabola of a ball? Yeah, give me like how does the parabola of throwing a ball show the Earth is not flat?
Yeah, because the way that it comes back down on the Earth gives weight to the evidence that mass attracts other mass.
Are you talking about?
So mass attracts.
I'm talking about gravity. Is what I'm talking about. Yeah.
Okay. So cool. So that can't work on a flat Earth.
That doesn't make the ground curved.
I agree with that, but so at least as far as we've been talking so far, the ground being curved is kind of the biggest point of the flat Earth theory, right? Like if the ground was curved, then the flat Earth theory would be proven wrong. Correct?
Exactly.
So you throwing
the first thing you said were correct.
To do with that zero.
Yeah. So if we have gravity,
it's a terrible argument.
If you agree with gravity.
Okay, so the Earth can be flat and still have gravity, whatever. But it's
not
like
exclusive to a globe.
You throwing a ball.
Okay, why can the Earth? Why do you think that the Earth can be flat and still have gravity? That was not the conversation we were having before.
Just trashing or flaming your argument because you said I threw a ball.
No, it's fine. You can trash my argument all you want. What?
Yeah.
Why do you think that the Earth can be flat and still have gravity? Why do you think that?
I'm just trying to address your claim. That's all.
You said throwing a ball, right? Throwing a ball. That means it takes a certain parabolic arc. That means the gravity vectors in a certain direction.
When we talk about gravity.
That means, yeah.
No. Hold on. You guys apparently weren't a part of this earlier conversation. When we talk about gravity, we're talking about G. And G is a constant. It's actually a mathematical constant. It is not something that we're like theorizing against.
Yeah, it is theorized.
No.
You're talking about big G, not little G.
You don't even know what
G you're talking about.
When I say mathematical constant, I mean that it is a mathematical constant. It's something that we use as a placeholder when we go this plus G. We use G as the placeholder, and the G is the constant of gravity. Now, if we're saying the constant doesn't exist, gravity doesn't exist, we don't believe in the constant, then I don't know how you describe how you throw a ball, I don't know how you describe how you
because you don't understand. You don't understand the basic physics. That's your problem.
Well, no, I do.
So you're conflating the universal. No, you
understand basics.
No, listen. Stop talking for a second. You're conflating big G, which is the gravitational constant, with little g. To predict the arc of a parabolic projectile, we use little g. We don't use big G.
That little g is still g. G is g. It's a constant. It's a gravitational
G is not g.
Constant.
There's a big G and little
yes,
g.
It
there's
is.
the gravitational constant, and there's the acceleration from gravity. Okay, they're not the same thing.
They are the same.
There's F equals G times M1, M2 divided by R squared. And then there's F equals
Big G and little g are the same thing. They are the same thing.
No,
how
they're
are
not
they
the same thing.
Explain to me how big G and little d are.
I just did. I just gave you two different equations.
Which equations? Go for it.
Okay. The universal law of gravitation is an actual law, but it's a geometric law. It's not a physical law. Is F equals G times M1, mass 1, times mass 2, divided by R squared. That you don't use that formula to calculate the arc of a parabola. You use the gravitational acceleration, which is little g, which is 9.8 meters per second squared, which can be approximated by F equals ma, right? Which they're two different things. They're two different formulas. Okay.
No, well, but wait, hold on. What is big G calculated?
Big G is derived from the oscillation of from a Cavendish apparatus.
It seems to work out with little g. Have you ever tried to?
No, dude. Don't work out with little g because the M1 in first formula in the universal law of gravitation comes from little g. So we know little g from dropping things, right? We can drop things and measure their
M1 does not come from little g.
Okay, so where did they get the mass of the Earth? Where did they get the mass of the Earth?
By putting it into the thing that equated the equation. But the point is that little g, I'm not. This isn't the reason that they figured out little g versus big G. Big G and little g are the same thing, and I'm asking you to prove that they're not the same thing. Okay, then prove it.
God damn it. I just did. They're two different equations.
Big G and little g are variables in equations.
Big G
not equations themselves, right?
Okay. Big G is the gravitational constant, right?
Mm-hmm.
In little g is the acceleration on Earth due to gravity, 9.8 meters per second squared. The value for big G is different than that.
No, not really.
The value of big G is 6.6743 plus or minus 0.0015 times.
I agree with you. Where did we come up with the value of big G? And why do we use big G versus little g?
We don't use big G. Not for the arc of a
parabola. I know we use little g. We use observation.
Now you know.
What I was always talking about is little g. I was never talking about big G. You're talking about big G in mathematics. That's fine, and that's fair. That's a fair thing to talk about. But there's about pretty much everyone else in this conversation that doesn't understand the difference between big G and little g. Little g is the thing
it's only Globers that don't understand. All the flat earthers understand. It's only Globers that don't understand.
No, the flat earthers don't understand big G, little g, or any g. They don't understand g's at all. But
you're assuming way too much, bro.
Well, that's fine. You and I can discuss big G and little g, and that's okay. But little g is what I was always describing. Little g and the gravitational constant is a constant. It's a mathematical constant that describes, does not explain, does not...
It's not a constant.
It is a constant.
It is not.
It is a constant. Okay, why is it not a constant? What's the number there? Non-constant?
What is the value of it? What is the value of it?
I tried to tell.
Yeah, I know. I heard you. You were right.
Slat.
Holy fuck, Scott Mackey said I was right. Woohoo!
Well, you were right sometimes.
8.9 meters per second squared. Okay, so why are we arguing against constants? What are we
That is the value at sea level. That is the value at sea level. You go up or down in relation to the Earth, that value changes.
A little bit, yes.
Well, then it's not a constant.
It is a constant.
Oh, fuck me.
Ew.
It's a constant.
He pulled the Uno reverse card on Scott Mackey. This is what it's like dealing
Wait,
with you,
what are we doing? If I throw a ball to my son, hold on. If I throw a ball to my son, the parabola, I'm not using little g to calculate what the parabola is. I'm using little g times 0.00001% difference based on what elevation I'm at. I mean, come on, man. I mean, are we really going that deep into mathematics? Are we trying to do mathematics, or are we trying to, like, I don't understand the point of this conversation. When someone says, hey, gravitation is not a concept or not a constant, and I go, it is a constant, and you go, well, 0.001%.
Okay.
Maybe it's different sometimes. Okay, I agree with you, and that's fine. And if we're gonna have a conversation between mathematicians or between people that understand this shit, fine. But in a mixed group of people that don't understand it, I'm not doing that shit with it.
Okay, that's fine. Okay, but where did this start? Let's jog our memory. Where did this start? You said that a projectile taking a parabolic arc is proof the Earth's a globe when it doesn't even have the formula that would even indicate the Earth's a globe in it. All that formula says is things fall down. That's literally all it says.
Yes.
Things can fall down on a flat Earth. Why couldn't they fall down?
If the flat Earth is moving up at 8.9 meters per second squared, I guess.
God damn it. No one thinks that.
Yeah, where do you pull that out?
No, wait, hold on. There was a guy earlier in the chat.
It's 9.8.
There was a guy earlier in the chat that was like, how do you know that the Earth isn't moving up? And I was like, what do you mean moving up?
You're talking flat Earth society crap. It's not a disc in space accelerating upwards. Thank you.
She's talking Einstein crap.
No, I'm talking.
Yeah, it is Einstein
what
crap.
The guy just said was accurate. He was saying that someone was saying that the disc was accelerating up in space, and I didn't have any evidence for that not being the case. And
that's not what I said. That's not what I said at all. The reason I asked you about this was because you believe that gas has mass, and you believe that mass attracts mass. So gas, when it's above the Earth, right? When I go outside and there's air above my head, cool. That air has mass according to what you believe. So the Earth, it has mass according to what you believe. So I'm asking you to prove that mass is going to be pulled or attracted toward the gas's mass, right? Because you believe that gas attracts mass. So
I know, but like that's like you asking me, like, why doesn't my table make me smack my head into my table because it has mass and it would attract my fucking giant fucking head into my table? Man. It's so stupid.
That was the reason why I said up. The reason why I said up,
little bits of mass, little bits of mass, little bits of influence. Yes.
Yeah.
They're
so
small. It's not very noticeable. Yes, there are things that are not noticeable. When someone flicks you, it's not like you're drawn to their flick. When you sit at a table, it's not like your head is drawn to smack the table's head as hard as possible because it has mass and you have mass. You still have attraction.
It's not moving upwards.
There's still atomic attraction. There still exists that exists still. But it doesn't mean that you're like fucking flying around
it's not moving upwards.
Being sucked to the sun or whatever. It's very mild.
It's not moving upwards. You didn't include the context why I said that. And
I know that you think that I'm explaining this wrong, but I'm just saying, like, if you're sitting at a table, the table has mass and you have mass. It doesn't mean that the table makes you smack your head into the fucking table because it has mass and mass attracts mass. It has some sort of gravitational pull on you. Yes, that's true, but it's very minor. It's very small, and so you don't need to be like, how do you prove that I'm not just smacking myself into everything that has mass? Well, because you aren't attracted to it that much. Like there's
the reason no, that's not why. The reason I'm asking you about this is because when you're describing about what I said about the Earth being attracted to the gas upwards, you're not understanding, and you're basically trying to make it seem like I was saying the Earth is moving upwards.
It's like inward versus upwards. Like if you've ever been on like a teacup ride at the carnival, right? You're moving inwards. It doesn't matter what the rest of the universe is doing. Right? Like you're looking at yourself versus the forces that are acting upon you currently. You're not looking at the universal constants.
It's not. Does that make sense? It's not moving upwards.
No, you're moving. Yeah, you're moving away from the center of inertia or towards it or whatever it is that you're doing on the teacup ride that you're doing. It's not global. It's not universal. None of the physics that are acting on you that you're feeling are global or universal.
So the Earth is not moving upwards. Okay, we agree. Do we agree with that? Earth is not moving upwards. Do we agree on that?
The Earth.
Yes.
I have no idea what you mean. Yeah, I mean, yeah, I agree that it's not moving upwards in compared to.
Okay, good. We're clear.
What? Right. I mean, compared to what? Like, if you're
above our head, above your head. It's not moving above your head. Agreed.
It's not moving above my head. Yeah.
Okay. All right. We're good then. It's not moving above. Okay. We're good. We can move on.
Yeah, but it doesn't matter where my head is. Sometimes it could be moving above my head. Sometimes.
Okay.
Depending on where I am.
All right. When do you see the Earth moving? Go ahead. Or where do you measure it? How do you prove the Earth is moving?
You don't prove the Earth is moving. You just prove that you are moving compared to other things.
So you can't prove the Earth is moving?
No.
Really? That's not.
Yes.
That's actually not what the mainstream. I know you may not agree with the mainstream, but according to the mainstream globe believers, they actually do believe that they have proof that the Earth is moving. Do you want me to give you a hint?
Go for it.
Have you heard of the Foucault's pendulum?
Yes.
Okay, and you agree that that's not proof the Earth is moving. So you're with that. You actually agree with the flat earthers. Actually, you agree with me that the Foucault's pendulum does not prove the Earth is moving.
I think Foucault's pendulum does prove that the Earth is moving, but I don't.
Why didn't you say that? Why didn't you say that?
No, because I think this is like a hard conversation now. I'm not understanding why do you disagree with that assertion?
You just said you can't prove it like 2 seconds ago. 2 seconds.
You can't prove it beyond a reasonable doubt, right? Like, and so we're talking about epistemology and like ontology here. Yeah, sure. Yeah. No, and I agree with that. And so How about with what you're saying, because I'm wondering like what it is about the things that you're saying that you disagree.
Okay.
I just don't understand your perspective, and I'm trying to ask you, and you keep. Hey, hold on! You keep redirecting me instead of just answering the questions that I'm asking you. So
let me make it very
simple, because
I'm gonna make it simple.
Okay.
Okay. Very simple. True or false?
Okay.
The Earth cannot be proven to be moving, or that's kind of weird the way to say it, but yeah. True or false? You cannot prove that the Earth is moving.
Okay.
True.
I'll say true. I don't think you can.
All right.
I don't.
You're with us. All right. You're on your
base. I think we have a lot of mathematical things. That's fine. Yeah, no, you and I agree on that. But I think we have a lot of mathematical things that give us evidence that it.
Palestine is
flat. And that we are not moving. Right.
You're with us, bro. You're almost there. You're almost there, bro. You're almost base.
Okay. All right. Yeah. No, I'm almost there. Okay.
Your mind is
so wait. So if I'm on a train and I see someone outside of the train and I wave at them and they're moving by, how do I prove that they're not moving and that I'm moving? How do I figure that out? How do we do that? What do we do?
You have to go outside. I'm assuming you have to go outside the train. I'm assuming.
No. I'm on a train. I'm on a train.
On it. Oh, I don't know that.
And I look out a window and then there's my wife, someone waving goodbye to me, and then she's going away from me, right, backwards, and I'm on the train. Most people would just be like, okay, well, I'm the one that's moving. How do I know that I'm moving, that she's not moving? What if I'm just counteracting the rotation of the Earth? How do I know? How do I understand?
But why would you?
How do I determine?
Wait.
No, I'm not assuming anything. How do I determine that? How do I determine what's moving and what's not moving? How do I determine that? Do you know?
If you're inside the train and you're not going outside the train, I don't know.
Yeah.
I don't know.
I'm inside the train. I'm looking out the window and someone is moving past me. Right? Obviously. You see someone, they're waving goodbye and they're going some direction. Yeah. How do you know that they're not moving and that you're moving? How do you know?
Yeah, I just assume. It's my assumption. I don't know.
Okay, cool.
Okay,
so why do you pit that against my... Wait, hold on. Why do you pit that against my observation of the math that absolutely works out, that you are the one moving on the train? It absolutely works out that way. Just like when you throw a ball to the sun. It works out. The math works out that way. And I'm saying, hey, it works out that way. I don't know either. So me and you, we're in the same position. We're both on the train. We look out, we go, I don't know if I'm moving. I don't know if the person outside of the train is moving. We both don't know, right? But then we try to calculate it and we figure out that the math works out every time that I'm moving and that they're not moving, and that I'm just moving in relation to them. We actually find that out. Einstein figured this out. And so I don't understand why we would just say that this math doesn't work.
Is math superior to your senses? Is it superior?
Yeah, no, it absolutely. Yeah, okay, wait.
About?
Math is definitely superior to our senses. Of course it is.
Okay, yeah. Then you can just then in that case assume I'm gonna choose at my own detriment, right? At my own disadvantage to trust my senses, and you go ahead and trust the math, okay? That's where we're gonna agree to disagree there.
but wait, why choose your own senses over math? I mean, math is also your own
I'll give you a specific example. They have all sorts of models for weather that'll predict temperature, rain, all that shit.
Oh, now, I don't want to go into meteorology.
I can watch the weather. No, it's math, right? So I can watch the weather, and I can go, the weather report says it's hot out, or I can go the fuck outside and feel that it's cold and put my jacket on. Okay?
Sure.
Yeah.
Yeah.
There's an example of your senses being superior to mathematics.
No, that's not an example of that. No, that's an example of your senses being superior to understanding the outside temperature to mathematical models that don't understand the outside temperature.
Yeah, thanks for proving my point. Mathematical models. Thank you. Game over. And by the way, Einstein's theory, Einstein himself said there's no optical experiment that can prove that the Earth is moving. Okay? Because relativity means that everything is some
Okay,
relative motion.
imagine that I agreed with you. Imagine that I agree with you that the Earth is flat and it's not moving. I don't. But imagine I did, and then I'm on a train. I'm on a train, and I go goodbye, and then you go left. You know, I'm looking out. I'm looking out my left side, and you go left, and then I go. Well, I don't know if he's moving or I'm moving. How do we figure that out? And we figure it out via mathematical constants like g, little g, that explain how we deal with objects. And it explains it every single time that we try to calculate it. Explains it every time we try to do anything with it. If I try to throw a ball to my son or my dog or whatever, I use little g, and I can figure out the parabolic arc. We can figure it all out. It's mathematically proven. It makes sense. It all makes sense. And then you go, well, none of that is true. I don't agree that any of that is true. Well, okay, then what do you have in response to that? What do you have?
Are you done talking in response to what? A bunch of word salad gibberish?
What is how do you
so we get more word salad gibberish.
To relativity. How do you respond to relativity?
Relativity predicts that you can't detect the Earth's motion. Your analogy about a train is inequivalent. Is not an equivalent.
I'm not talking about the Earth. I'm talking about you.
I'm going to go through every point you made. Okay, I'm going to go through every single one of them. In Einstein's theory, you cannot tell if the Earth is in motion or if everything else is in motion. You can't tell from looking. That's what the math says. Okay?
Yes.
So the math says, no, we can't tell from that math. Your analogy about a train, that assumes that the train is going at a constant velocity in a straight line. Well,
no.
Yes.
No.
Well, you feel acceleration, right?
No.
No.
You don't feel acceleration? Yeah. Really? Come on, bro.
Okay. I'm done with this shit.
Why?
No, that's it.
Oh, he muted. Okay, he's muted.
No, I muted him, man. It's done.
Yeah. I'm surprised he said no to that. Honestly, I didn't. I wonder if I don't know. Yeah, that's weird. That's really weird. Good times. Good times. Oh, bizarre. Does anyone know that song, How Bizarre? Oh shit, I just see him. I see him in the chat typing, sorry, the answer is yes, I feel acceleration. I did not hear you correctly. Damn. I just read. But there's no way. Come on. I know he heard you correctly, man. Come on. There's no way. Oh well. Okay, well eventually eventually we'll unmute him.
Notice you left.
Oh, he's gone? Yeah.
That was freaking painful, man.
Yeah.
You don't feel acceleration. See, that's when, like, he's just saying anything. He's just saying it contrarian because it can't be shown up by a flat earther and he's half cocked.
Yeah,
I fucking hate when they come with that attitude, man. Everything a flat earther says is wrong. I hate that shit. So it don't have to be like that.
Yeah, I don't know. It's just kind of strange.
I'm telling you, dude, we could write a whole psychology book just on this. Just on our experiences of this topic.
You know what I think? It's because they grew up. I mean, we grew up with, like, this is like multiple decades, at least like 1 or 2 decades of believing something, you know? It's like going through withdrawal of believing something for like 20 years, you know? That's what it's like. It's intense.
Yeah, it's almost like a drug addiction. It's like this weird combination between, like, the irrationality of someone that's, like, addicted to drugs and they just want to get high and they'll just say anything, and, like, a child that wants a cookie and will just, like, do anything, like, they'll just say and do anything to preserve their ideas. It's just really odd to me. I mean, come on, dude. You don't feel acceleration? Come on, man. Even he knows that's not right.
Yeah, that's true. We had the good news is that he's been here for a while, so at least we got, you know, he had a decent amount of, like, opportunity to, like, learn. So yeah.
I think I've heard him before, but I think he always comes in here hammered.
So have you found any physicist that says that we can feel acceleration?
That we can?
Right.
I don't need a physicist for that. I only need, like, a freaking automobile.
Yeah, so that's right. We only feel acceleration, not movement.
Yeah, you won't feel a constant velocity, right? You're only going to feel a acceleration, a change in velocity.
Yep.
Acceleration and deceleration. Say speed because velocity is a vector. Yeah, well, we had a guy saying that said his train analogy was no good because that's not an accelerating thing. He's like, we don't feel an acceleration. What are you talking about, bro? He was a little cocked, though. Yeah, whatever.
I think you got it backwards and meant to say we don't feel motion or speed. We feel acceleration instead of motion.
He was getting a lot of things backwards. He was conflating big G with a little g, saying you use big G to plot a parabolic arc of a projectile, which is obviously not correct.
I wonder if it was just like the heat of the moment that he was, like, just saying whatever, like he wanted, like, an instant response or something. I don't know. I'm just giving him too much. I'm giving him too much charity.
Yeah, you should give him, like, well, I have no problem with that. Give him as much benefit of the doubt as you can. It still looks bad.
Yeah, it is weird.
You can look at him in the best possible light, and you're just like, what the hell? What was that?
Yeah, because I'm pretty sure he did hear you correctly. I'm pretty sure.
Yeah, he heard me. I just think he was just being a contrarian, man. They get in that mode, like anything you say, I'm gonna contradict.
Right,
because they think it's a trap, like we're trying to trap them, right? That if I agree with them, there's a trap behind the corner that they're gonna lay on me, so I'll just not agree.
Yeah.
And yeah, well, that's partially true. There is a trap, but it's also the trap is truth. So
yeah, that's
trapped
how.
by the truth. That ain't my problem.
Okay, to be fair, I do that sometimes. Like anytime a Glober asks me, how do you have, or what did they say? Show me something that moves without a force, or they say something like, you need force to move, right? Or acceleration. I don't know what they say.
I mean,
but
that's almost saying the same thing, though.
Yeah, it's redundant.
Because if you, it's like almost a tautology. Because if you look up force, right, the thing, whatever that is, that causes something to change its motion, right? Speed.
So actually, I have a question about that. So, when when it comes to light, does light need a force to move as well, or is it just, how does it move?
I mean, technically, for light to be emitted, there had to have been some. Well, I mean,
because that's the thing that I always.
Because then you get into like weird quantum mechanics. I mean, depends on like what level you want to go to.
Okay, forget light. Light's too complicated.
No, I mean that applies to all electromagnetic radiation. So there's like
yeah. Forget.
There's like like they don't use like they use momentum. They don't use like they use position and momentum. They don't use like
force.
Like a force, yeah. But momentum's almost like it's kind of the same thing, but it's kind of not. It isn't. I mean, it is, but it isn't. I guess it has some different properties of a force. I have to think about because light itself has a momentum. So you can shoot. It's called radiation pressure. You can use light to actually push shit around because it has a momentum, right? So we get into like the mass energy equivalence nonsense, right? That if a photon has X amount of energy, it's equivalent to X amount of mass, right? So that's why it becomes like interchangeable, right? So you can like shoot electromagnetic radiation or something and push it. But they wouldn't model it as a force, they would model it as a momentum. So they would be like, okay, the momentum of the light is imparted on the momentum of say it's a sail or a solar sail or something, and then they would do the equation of how much. Yeah, it would be a force because they'd measure it in newtons. So yeah, it would be. I guess it would convert to a force.
So light does require a force to move.
To be generated in the first place, yeah, because a light is caused by the emission of light is caused by change of the state of an electron. Basically.
Right. Okay. Gotcha.
So when they first, I mean, especially just go back to like the first experiment was like Hertzian waves, right? So like basically he made like a spark gap, so spark would go across this gap. They turn up the voltage, so spark would go across this gap, and they picked it up at some distance away. This change, this electromagnetic radiation, they could pick it up, and but yeah, you need something to make that spark in the first place, right? So you need a current, and we can't make a current without some type of motion, right? So we make currents by, moving a magnet inside of a coil or outside of a coil or whatever the case may be. So for light to be generated or electromagnetic to be generated in the first place, you do need some sort of motion or a force because this is actually pretty important. You need a changing a changing magnetic field gives rise to an electric current, and a changing electric current gives rise to a magnetic field. Some people just think it's a current, but it's actually the change in current. And that change can be an acceleration or a change in direction. So if you make a coil of wire, the charge is actually moving it's changing direction because it's in a coil, right? So it's always like, wrapping around in a spiral. So you do get a change of momentum from that going over the coil. So yeah, I guess you do need a force of some sort, or you could call it a force, I guess.
Got it.
I mean, light just doesn't start itself, but I mean, not that I know of.
Yeah, I think light. I didn't mean to bring it up. It just makes everything. Talking about light just makes everything more complicated than it has to be. It's everything like.
I mean, then on the other hand, there's the Casimir effect, which is supposed to be vacuum energy or something. There ain't no light involved in that. So if you take two thin metal plates, you put them really, really close together, they'll snap together as if they're pushed together from the outside, right? As if there's a force. And the theory of that is that so there's ambient electromagnetic radiation around everything. And when you start closing the gap, you start limiting the wavelengths that can fit in that gap, right? So if it's a 1 millimeter gap, you obviously can't fit a 2 millimeter wavelength inside that, right? It's too long, can't fit in the gap. So as you get this gap smaller and smaller and smaller, you create like an asymmetry between the wavelengths inside the gap versus the number of wavelengths outside the gap, right? So that asymmetry causes a force that pushes the plates together.
Gotcha.
The vacuum energy, but this electromagnetic radiation is the vacuum energy, supposedly. I don't know if that's ever been experimentally proven or if it's just a theoretical mathematical consideration. Yeah, I think the word force is just a tautology, man. You're basically saying the same thing. Show me motion without a force. Well, you're literally just saying the same thing. You defined force as a change in motion. And you're saying, show me a change in motion without a force. It's the same thing. You just took all those words and you took a phrase and made it into a word, then ask why, show me the word without the phrase. It's just dumb. And I think things like this are actually kind of important in a way because they reveal something about the logic of modern science and the logic of these concepts and the argumentation that like how flimsy it is. Like gravity. Gravity is a perfect example of how flimsy this shit is. Oh, mass attracts mass. Okay, prove it. Drop something. It's fucking dumb. Sorry, I just think that's dumb as shit. Planets orbit the sun. How do you know that? Drop sun. Earth's a globe. How do you know that? Drop sun. All that shit is dumb to me. How do you get from I watched something fall to now I live on a wall?
Imagination.
Yeah, I mean, why didn't if it's so obvious, right? Why didn't everybody figure it out like 5,000 years ago? They're like, "Fuck, man, that coconut fell out of a tree. We must live on a ball, brothers." You know, no one did that. There's a leap of logic to go from one thing to the other.
Actually, I changed my answer. It's imagination plus billions of government funded education. Billions of dollars worth of education and the entire education system.
Miseducation. Is that a word? If it ain't a word, we should coin it.
Indoctrination. Yeah, there should be miseducation.
I actually don't like the word indoctrination because I don't think the teachers are trying to indoctrinate the students. I think they're just doing what they were told to do.
Yeah, that's true.
And I don't even think the people that they get their curriculum from are trying to indoctrinate. I mean, yes, in some subjects, yes, there's indoctrination. But I don't think like the globe is intentional indoctrination. I just think it's like, as far as I'm concerned, it's like going to Catholic school and they teach you about Jesus. If you go to a secular school, they're going to teach you about the globe. It's just like, it's the school you're in. If you go to a freaking, madrasa, you're going to learn about Islam. You know what I mean? It's like, that's like the core curriculum. You're not getting away from it. It's the type of school you're in that they're going to teach you that stuff. And it's not indoctrination. It's just like, yes, this is our foundational common belief, and this is why we're going to teach it.
Yeah, teach what? Teach what? Teach what, huh? Teach me, bro. Teach me.
They don't encourage critical thought, though, isn't that indoctrination?
Come on, tell me, what are you teaching? Tell me.
Mr. Lee, if you're about to get muted if you don't shape up.
Yeah.
Okay.
That's a Glober. He's not a flat earther, so he's giving you a fair warning. He's on your side. Mr. Lee's going to get Bruce Lee.
What are you talking about?
If you pause for 30 seconds and listen to the conversation before you jump in, then you might learn what we're talking about. And at an opportune moment, feel free to jump in. We welcome you here.
All right, go ahead.
We're talking about the education system and whether it's indoctrination or miseducation or what the issue is there. Because obviously everything they'll teach you isn't factually accurate, right? It's a whole I mean, yeah, some of it's agenda, but I don't think all of it's agenda. The agenda is sometimes monetary, the agenda sometimes is ideological. You ruined his troll, Matt. He left.
I know.
Oh, he left?
So, Ray, you said something about critical thinking. What?
Yeah, no, I was basically just saying that if the education system or the teachers themselves aren't encouraging critical thought, that kind of lends itself to becoming indoctrination. They're teaching people what to think rather than how to think.
Yeah, I agree with that. Rote memorization. Memorize this, okay, and then write it down in the test. And the person that memorizes the best is the one with the highest score. I think that's silly. I mean, I don't think that's very good. But I don't know how the education system is set up in where you're at. But I know in America, there's a lot of financial considerations on what is taught. Because our system is, we have local school systems that are paid for typically by property tax, depending on the state you're in. In my state, it's property tax. But that isn't enough to run the school. So they have to go to the state Department of Education to beg for money. Well, they're only going to give you money if, under certain conditions, right? You have to teach certain things. But then there's another source of funding called the U.S. Department of Education. And then if you want their money, you got to teach what they say. And then there's all sorts of other people like NASA. NASA does this. They'll give you curriculum to teach to fill the gaps, right? Because a lot of things that are taught, and at least in America, they have to be purchased for a price. So we have Common Core here, and Common Core is patented. And it's the law that it has to be taught here unless your school gets an exemption from teaching that. So if you want Department of Education money, you got to teach Common Core. If you want to teach Common Core, You have to buy their course material, and then your teachers have to teach the course material. So the teachers are stuck just teaching whatever some school administrator decided that it was going to be like the best thing overall as far as funding and education, whatever compromise that made. That's what's getting taught to kids. Not what's to make them smart or intelligent or anything. Just it's sad. It's a sad state of affairs, man.
You also forgot about the lobotomization part. Go ahead.
The lobotomization part. I don't know what school you're sending your kids to.
So it sounds like over there, essentially, if you live in an affluent area, you know, they're going to be paying more in property taxes anyway because they're earning more. The property's worth more. Therefore, the school's going to be funded better. And
exactly.
So if you're in an affluent area, you're going to be getting the best education, and if you're from a dirt poor area, you're going to be getting a dirt poor education. Yeah, that sounds pretty flawed. So in Australia, as far as I can tell, anyway, it's each state has its own education department and its own curriculum, but the curriculum still falls under sort of like a federal level of regulation. So all of the state schools or public schools here are essentially on the same curriculum and they're taught the same basic syllabus. So there's no real drama. Like the school itself might be a little bit nicer in terms of, you know, the building or the property or the grounds or whatever, that there might be variation there, but in terms of what they're being taught and what teachers and things like that are being paid, it's pretty much standardized across the board. So you tend to get a pretty even balance with education. It's not going to be based so much on, you know, whether you're from a wealthy family or live in a wealthy neighborhood. Obviously, you could go to private schools if that's the case, and you might get a better education there. But for, you know, Joe Blow lives up the road and everybody else, they get a pretty high level of education. But a lot of that as well is because in Australia we have a lot of socialised services. So, you know, like free public health care and all that sort of stuff. I mean, it's free. It's not free because we pay our taxes and our taxes are what pay for it. But it's a lot of socialised stuff here, whereas you know, in the US, I think a lot of it's privatized really more than anything. Is that if I understand correctly?
Yeah, I mean, I gave you kind of like a general view, but as far as like, it's really locally based. So like how the local, whatever town, city implements it can vary a lot because we also have things called school choice. So people have started charter schools, and there's a little scammy too. That was a little scam that was running for a while, because the problem you said, right, is that you have a place like New York City, and then, or any city, and then like the people from the low economic districts would go to shitty schools, and then the people that were in the rich places, they'd go to good schools, and you know, the government got involved and was like, it's not fair that these kids are stuck going to crappy schools, so let's give them school choice so they can pick what school they go to. And like, we're gonna you know, spread the cost. So they also made these things called charter schools, which were like a different type of education. You know, supposedly that was the ruse, and they gave a whole bunch of grant money. But a lot of these schools, they ran for 3 years and then shut down. But the thing, because basically they got like a huge, gigantic grant to start up. So the administrators would just take all the money and salary and then just shut the place down after 3 years. But all that stuff's gone. So there are still a few of them left. But what they get to do is that they get to just have the administrative costs, and they just get to build a town, right? So like, you'll be like, so you have all the, say you have a small city, they have all their public schools. Now someone can start a private charter school and have students, and then build a town, a sum per student, regardless of what they teach, regardless of what they do. Now, of course, they have to be in compliance with like Department of Education guidelines, whatever that is, right? But they don't have the same level of oversight as like one of the schools that are funded by, you know, the particular town or whatever. So it's But like I said, it varies. In my state, they do it by property tax. But if you go to New Hampshire, which is just north of here, they don't have property tax, and I have no idea how they fund their school. Or no, they only have property tax. They don't have income tax. The point is that, you know, how this all pans out depends locally on how they want to like fund this stuff. I think the bad part is that what ends up at the level of the children, what the children are consuming as educational material, has all sorts of considerations, political, economic, ideological, before they ever even like get to curriculum. It's not just like what's the best thing to teach the kids. You know what I mean? It's not that. That's not the consideration. It's all this other stuff. You know what I'm saying?
Yeah, that's pretty crazy. It's and every kid in the country is going to get a completely different type of education. So there's no standardization. It's that just sounds like chaos to me.
Yeah, I mean, you can go. I remember, this is probably like 20 years ago. I remember a kid telling me, "Oh yeah, I was taking like C++ courses in frickin' 6th grade." Like what? like out in California, they're like, some of the schools out there, they're teaching kids like college level stuff in middle school, high school, and other places like they can't even read and write at 12th grade level when they graduate from high school. So it's like you said, it's like there's no national education standard. And I mean, there's reasons it's like this in America. I mean, the original reason it's more religious people. Yeah. I mean, there's religious parts of this country that don't want the government teaching evolution, things like that. The government won that fight. And so that's how schools like originally started. They started at the local level, right? We used to have what they call one-room schoolhouses, right? Schools were set up by towns, so that original infrastructure still exists, but they have this other monolithic top-down thing that's actually administering something that started on a local level. It's just a mess, dude. The American education system is a fucking mess.
Yeah, it sounds crazy. You've got the two sides, like you said. You've got it working from ground up and then from top down.
Yeah, and that's the thing. You can't fix it because to fix it, you have to centralize, right? But then because it's kind of like administered at the local level, there's resistance to centralization, right? And then when you centralize, you have all the freaking grifters that are trying to make money off the federal government through grants and money and this, that, and the other thing, contracts. So it's the problem is there's a profit motive in just about everything in America, and that's kind of the problem. Is that the incessant profit motive that exists in things which there should be no profit motive?
Well, you're finding all these issues, but at least they're all vaccinated.
Quadruple boosted, buddy.
Yeah, all the issues that you're pointing out, all the problems, all the stuff that we go through, but at least we got them.
Yeah. I've been wondering if like the school system got like a gigantic grant to give because they were sending home like COVID tests, like the antigen test. They were sending that shit home every fucking week, man. Like, but the thing is, even when it was all gone, they were still sending it home. It's like, you got a warehouse somewhere with all these? You got to get rid of them. Like, stop sending these fucking things home, man. I got a stack of them like 10 feet high.
Just consume them. Do what you gotta do.
Are they edible?
If you want to.
my personal opinion is we should go back to the one-room schoolhouse and make a bunch of little tiny schools instead of having giant fucking schools with hundreds and thousands of students in it. So the way the one-room schoolhouse worked is you'd have mixed grades, right? You'd have some first graders, second graders, third graders, fourth graders, all the way up to like high school. They'd all be in the same class, right? But it was a requirement for the older kids to teach the younger kids. And the benefit of this is that you will understand a subject better if you have to teach it to somebody else. Because if you can't teach it to somebody else, you don't really understand it.
I agree, and then at the same time, I worry that becomes a blind leading the blind problem.
Well, yeah, I mean that could be a problem, right? Because like if the head is, as they say, a fish rots from the head. So if you got a stupid teacher that makes stupid freaking 18-year-olds, they're gonna teach stupid 17-year-olds, and then 16-year-olds are gonna be stupid, and then like everybody's gonna be stupid. You know what I mean?
Yeah. But it might. I mean, it might not even be that the teacher's stupid. It just takes some of the kids to not fully understand it, and then they're teaching their lack of understanding to the next kid, the younger kid, and so on. It's a bit of a slippery slope. It just
actually, there's a lot of like tech stuff that can be self guides. With self guides, people will learn a lot of things just by doing it themselves. But there's other stuff that it has to be applicable, like mechanics and things like that. But self-taught guides are pretty efficient. Depends how they're designed. You can learn a lot by just reading a guide of something and kind of go through that. But then there's the application of that.
Yeah,
so you need the actual people to teach you.
I think if you've got self-help guides and you've got something that you can actually apply it to, like you can't just sit and learn the theory and be good with it. You need some practical application or practical use of what you're learning from those guides, right? So you could do something like that with if it was programming, you could be learning stuff, and then if you've got like a sandbox, you can just start testing your knowledge and creating things. Then you can, that's a good way of doing it. You can actually see that what you're doing is working. Or if you're a mechanic and you're doing self-help stuff, you can actually try and fix or create the thing that you're trying to do. So there's practical application there. So I think in that situation, it works well. But self-help guides where you're just reading theory and not being able to apply it anywhere, I think that becomes
that would
useful.
be silly. Just to teach someone something that they're not going to use ever in reality. I mean, that's just that self-guide is just like a globe dart self-guide, right?
I don't think
you want a self-guide that is used in reality, self-guide that is teaching you things that you're going to relate in the realist level and then you're going to utilize. I mean, obviously, you're not going to talk about globes. You want to be efficient.
Well, there's the other problem with self-help guides. They're not very good if the people using them aren't motivated.
Oh, yeah. No, you need no motivation, 100%. Yeah, that's what you need since the beginning. Yeah.
I think they should be teaching critical thinking, and I actually think if you really want my real opinion, boys and girls should be separated. They should not be going to school together. Boys and girls learn differently. They learn differently. They should be separated. Yeah, I mean, boys learn differently. I bet you did a lot more active. Girls did a lot more active stuff, though, right? Well, of course you're horny and shit, but I mean, we're talking about your education, not your social life, right?
Exactly. No, exactly. What I'm saying is that girls, I think, boys and girls in school, particularly in high school, it's a distraction.
It is.
Yeah, it is.
Do you know what I mean? Like,
facts.
And yeah. So I went to an all boys school until I was, I don't know, maybe 15, and then when I moved to Australia, then I went to a co-ed school, and I could tell the distraction was there as soon as there were beautiful girls running around everywhere. and my head was not in the game. I was then worried more about, trying to get a girl to like me, or and all of that stuff that was never a factor before sort of came into play, and it did make things a bit harder. But yeah, it's not that common anymore.
No pun intended, right?
I want to say that in school, I think girls mature a little earlier than boys, and they start going after the boys before the boys start thinking about that stuff. That's what happened to me.
But they're only doing that to compete with each other because fucking girls hate each other.
Possibly, yeah.
They can't get along.
Yeah. Girls are highly competitive, man, especially young girls.
Well, when I was in middle school, girls were the ones that taught me what a girlfriend was, what a kiss was, what a hug was. They were the ones teaching everything. The girls, the boys didn't know anything. It was the girls.
Oh boy, I'm not touching that shit, man. I'm staying away from that right now. But my point wasn't that. My point was they could teach. You don't have to have the same type of education system with boys versus girls. Girls learn better in a specific way, and guys learn better, and boys learn better in a specific way. That way you can separate the education system instead of the one-size-fits-all shit. I think that's the major problem, is the one-size-fits-all. That needs to just go away. It just needs to stop. Like, we're not widgets. Human beings are not interchangeable widgets, man. We're just not.
Yep.
There should be like the market, the free market out there, where people kind of pick and choose certain things, so the economics kind of flow with that. But now we have people that choose the winner and losers, and they get to decide what type of job you should be getting, right?
Because it reminds me of something, dude, that really makes me mad. Do you ever hear the book The Bell Curve? It's like people in Africa have the lowest IQ on average out of any population, any group population. People in Africa, they're like in the 90s or something. And that test, this is the way I look at it. Take a white person or whatever group has the highest IQ, stick them in Africa, right? Just drop them off in Africa, have them take their IQ test in the fucking jungle. See how that works out. Right? Yeah. You see what I'm saying? Like, their brain is wired because they have to worry about fucking hippopotamuses and shit, right? Eating them.
Mm-hmm.
Like, they're not worried about fucking what number follows in the sequence. They're worried about, is that going to kill me? And their brains are wired that way. And I think, like I said, that this one-size-fits-all stuff, man, it's so... It's foolish,
how I'm gonna cook this venomous snake that it won't kill me.
Yeah, it's suboptimal. That's what I think the word is.
Look, we'll have them take the IQ test in a lion's cage. We'll see who scores higher, right? The African or the fucking white guy from Europe.
Right.
The white guy from Europe is gonna score like a 3. He's be thinking about the lion the whole damn time, and the African is gonna be like petting the lion and just like chilling to doing his test and get
eating the mosquitoes. Eating the mosquitoes and the flies, and the other guy's like, "Oh, mosquitoes! Oh, a fly!" Oh. There's some dirt here.
Yeah, that's kind of like growing up. Like you could probably compare it to like growing up in a dangerous neighborhood versus like being insulated versus, I don't know.
Yeah, man, your brain just gets you develop differently. You're looking for different things, right? Your attention is on is that guy packing? It isn't like oh man, all the numbers in his license plate are divisible by 6.
Right.
Okay, since y'all brought up the bell curve,
I wonder if the Chinese did it on purpose, the one girl policy, because that makes it to where the only females that are around are going to have the absolute creme de la creme to choose from. So they're going to pick the smartest, strongest, fastest guys over there. And I wonder if they're going to actually raise their, IQ by standard deviation for doing that.
Oh, I see. The other ones will be weeded out of existence because they're only because of hypergamy, or not even hypergamy. It's just natural competition, actually.
Kind of weird because the Africans are the least vaccinated, so they're actually the healthiest people, but somehow the lowest IQ. And like people get, vaccinated, they get metal in their brain, and then they could just like remember everything. They get savant abilities and stuff.
Yeah, the IQ test. There's just problems with the IQ test. I think generally they test something that's so specific that I don't think that it like. They try to like correlate like, oh, IQ means you're not gonna live as long, you're not gonna have as good as a job, like people in Africa. There's all these other considerations that also are determining factors of that, right? So
India in the IQ test, they're gonna get like, is Earth a globe? And they're gonna say no, so they failed the IQ test. Go ahead, my bad.
Well, no, the IQ test is basically pattern recognition. That's all it is, pattern recognition. At least the mathematics part.
Recognizing things that you learned before. You learned this stuff before.
No, it's general intelligence. How fast you can process a problem you've never seen before. That's really what it tests, right? But there's specific types of problems, right? They're abstract problems. Whereas, yeah, they're abstract. They're mental problems. Problems like where you sit there and you think in your head what the answer is. But there's other problems like practical problems like, oh my God, the dam burst up the frickin' river. Where am I going to move my shit to? Right? You know what I mean? You can sit there and frickin' meditate on it, but you really don't got time for that.
Mm-hmm. Like, I don't know. I've seen people getting like floods, and they between the community they grab sand, put it together to save, I don't know, their cows or the harvest, and they work together to do these things. They're not taking into account the radius of the earth while they're filling sandbags to protect from the flood.
You sure? Like they have to, man, because it now pulls uphill. Well, I mean, they've tried to correlate IQ with like outcomes, like health outcomes, poverty outcomes, wealth outcomes, all this stuff. But like, that's applied to egalitarian societies where people aren't in any mortal danger most of the time. Right? In the countries where people are in mortal danger most of the time, they're not still that way because they want to be that way. They're that way because of the people that have the egalitarian societies are suppressing them and stopping them from developing in the first place. So I don't think IQ's all it's cracked up to be, regardless of what Jordan Peterson says.
Yeah, a lot of smart people. Smart people are dumber a lot of the time. They like believe things that aren't true. Like they'll start explaining to you like how vaccines work.
Dunning-Kruger, you mean?
Robot Polisher, he posted a video. It showed like it was the result of a study that showed. So they took lefties and they took righties. So like liberals and conservatives, right? And then they IQ tested them. So they had the range of IQs, and then they showed them facts. So these were facts. They weren't like opinions. These were facts, data that showed whatever the opinion they had about something was incorrect. And the people that were least likely to change their mind were the smartest people. So the people that you would think, right, are only like they're more like they have more degrees, they have a higher IQ, right? They're going to just apply to the data and the science, and they're just going to objectively, without bias, evaluate the data and change their mind. They're the people least likely to change their mind.
That's what I call the second type of stupid. If you're too slow, you got like an 80 IQ, you can't learn anything because you lack the ability. Or if you're too smart, you think you've already been taught the subject very well and you know it and understand it, and everybody who disagrees, they're just dumb. Well, that's the second type of stupid. They can't learn anything new because of their supreme cognitive ability.
Right. Super proud.
Well, this wasn't like the conclusion. This is what they hypothesized as because of the result was that smarter you are, the more ways you have to rationalize even absurd things. So that's what they would do, is that because they're super smart, they can come up with various, post hoc rationalizations to why their viewpoint is correct anyway, in spite of the data.
Yeah, they're better at mental gymnastics, and they think they're smart. Yeah, exactly. So obviously I can't be wrong, and then they just.
Scott Mackey. Scott Mackey is a good example.
Yeah.
Mental gymnastics, dude. He's got like fucking 40 Olympic golds in a row.
Yeah, I think they're the people who suffer from cognitive dissonance the most.
Yeah, I mean, I'd have to agree with that.
Either he's lying, stupid, or trolling. Has to be one of those.
That is kind of how it. I feel like that does sound like when I used to believe that the Earth was a globe.
Damn it! I want to argue about something real, like the Earth is round.
When you say round, you mean like that flat table you have in your house?
Yeah, man, like that flat table is kind of round. It's a little bit rounded because of the curvature of the Earth.
So you put the globe on top of that table. Therefore, you live on a globe.
I put the globe on top of that table and I spin it around and I go, "Wow, that's kind of a really round ball." And you go, "No, it's flat." And that would make you the dummy.
No, actually, I say that is a globe, but you go, "Oh, I live on that globe."
Oh, okay.
That's the problem.
Oh, okay. Well, I think that
I recognize it for what it is. I recognize it's a globe that I've put on a table. Right? I recognize it for what it is, acknowledge it for what it is, a globe on a table. You go imagine fantasy ideas with it. And you start thinking about, I live in a globe. I look around, and everything I see is globe.
And the horizon disappears. Imagine, just technically imagine that we're on a curved surface. And you go, "No, we aren't."
Because you said
I know. And I know that. And then you say what? What do you say?
Why are you trolling, bro? Why are you trolling? Tell me that first.
Well, I just don't understand why you would say you know something that you don't know. Do you know it?
Know what?
That the Earth is flat.
Oh, I know it. It's measured and navigated that way.
The Earth is not measured or navigated in that way. So
yes, it is.
No, it's not. No, it's not.
Yes, it is.
It's also not. No, it's not. No, wait. It's absolutely fucking not.
I'm fucking trying to say something. It is actually observed and experienced that way as well.
Oh,
yeah. You should be asking us for evidence that what we're saying is true instead of just saying no, it's not. You should ask us, how do you know? What's the proof? You should.
He knows better.
No, I can't. I can do that.
He can't learn anything. He's not here to learn. He's here to teach you how stuff works.
No, I'm not. No, I'm not.
Yes, you are. Yes, you are.
No, I'm not.
Yes, you
are. Stop telling me what I'm here to do. Stop telling me what that.
Remember when you told me about the red rubber ball?
Yeah, I do remember that. Yeah.
You said that your house is not level, and when you put the ball on the floor, it rolls sideways down the hill, and therefore gravity. Remember that?
Yeah. No, I do remember that. Yeah.
There you go, people. Be aware of who you're talking to on the internet. Okay, be careful. Some of these people have driver licenses, so be careful.
All right, so are you ready to ask us? Are you going to ask us for the evidence of the flat Earth, or you're not? Or are you just going to say no?
Yeah, no,
no,
that's fine. What do you have that's evidence of a flat Earth?
All right, go ahead. Whoever was talking to him, go ahead. You can present it now. I don't know who is it.
It was the guy from. It was the guy
do
from.
We have any, or are we just like?
It was the guy from down south. The guy from down under. The Rain Rod.
Rain.
Or flat. Oh, the Australian guy. Perfect.
Oh, Flatman Ken as well was talking to him. Go ahead.
Yeah, go ahead. Go ahead if you have any. Go ahead.
What's the evidence of the flat Earth again?
Well, if you want me to present it, go ahead.
Celestial navigation.
Celestial navigation. Yeah, no, I do understand how that works. Yeah.
Cool.
So that's not evidence for a flat Earth.
So you take an elevation angle to Polaris.
Mm-hmm.
Yeah. That in and of itself requires a flat plane.
No, it doesn't.
Oh, okay. So how do you get an angle without a flat baseline?
Well, you get an angle with a flat baseline, and then you get good.
Right.
You
So
get
it's
good.
flat.
You get good enough, and that's how. How people.
So you get good enough.
Navigating.
Okay. No. So you think people were able to successfully
within a couple of degrees? Yes.
Navigate within a couple of degrees. Oh, okay. No. That's not correct.
There's like 360 of them.
It's accurate. It's accurate. Completely accurate. You use flat baseline to the horizon.
It's actually not completely accurate. It's completely accurate within a couple of degrees, as you know.
Accurate.
No, it's completely accurate within a couple of degrees. This
is how we've navigated the Earth forever. It's accurate.
Yeah. As you know, within a couple of degrees. Of course.
No. It only works if it's flat. It doesn't work if it's a ball. How do you get the ground position of a star and get an elevation angle to it if it's round, half the curve of the Earth?
Trigonometry.
Which requires a what?
Trigonometry within
a flat baseline, which is the surface of the Earth that you're navigating. It's flat, mate. I know it's hard. I
know that you think
it's flat, bro.
I know that
it's
you
all
think
good.
No, it's not.
I know that you think you can get angles from curves. That's brilliant, but you can't.
You can't actually
flat.
Get angles from
you
curves.
Can't.
Yes, you can.
No, you.
Yes,
oh,
you can.
Wow. Okay. Wow, you can get angles from. Do you know what the definition of an angle is?
I understand what the definition of angles with triangles are, but you can put a triangle on a sphere and still get definitive answers. Yes, you can. Yes, of course you can. And those angles of the triangle, when you put them on a sphere, are greater than 180 degrees, and you know that is also the case. And we can also get very accurate understanding based on that geometry. It's called Euclidean geometry with a curved spacetime, and we do that. We do it all the time. We do it whether or not we think the map is flat or we think it's curved. We do it all the time.
So you need a flat baseline, but
nope, you don't need any flat or curved baseline
to get an angle. Yes, you do.
All you need to understand is what's the distance between 2 points. That's all you need to know.
Okay.
No, that's not how you get an angle.
Yeah, you need to understand the
two straight lines that intersect the vertex
to get the angle.
You can't get an angle. You can't get an angle without two straight lines, my friend.
That's absolutely true. Those straight lines can be drawn on a curved map, or
Citation, please. Citation.
Or a flat map.
You feel free to provide a citation of how you can get an angle with a straight line and a curved line. I will wait here until you provide a citation. I'm more than happy to wait.
You can't do that, but Euclidean space-time.
Oh, so you can't get an angle unless you've got two straight lines. The baseline of which, by the way, when we're measuring elevation angles to Polaris, is the surface for navigating, which is flat.
You take flat lines. You take.
Bro, you're talking nonsense. You're talking absolute nonsense.
Okay. Apparently, I'm talking absolute nonsense.
You are. You're suggesting you can get angles from curved baselines. It's just.
No, I'm not. No, sir, I'm not. No, I'm not.
Well, if you're agreeing with me, which it sounds like you are, then you would agree that the flat baseline that's required when you're taking an elevation angle to Polaris is the surface we're navigating, which is flat.
You are taking a straight line from your position to Polaris.
No. You're taking an elevation angle. You're taking an elevation angle up to the star, but the baseline
is still a straight
the horizon,
line, correct?
That goes to the GP of the star, which is the ground position of the star.
No, it's still
that line that stretches from you.
Line. Yes.
That line from you goes to the ground position of the star. That is a flat line. It's flat. No, it's a flat line.
No.
Baseline used to get an angle.
So
and that flat line goes all the way to the ground position of the star. I'm confused as to how you think curve comes into
straight geometric lines. The shortest distance between 2 points is a line, correct?
Okay. Yeah, I can probably agree with that. Yeah.
Okay, so I have a point that I am at. I have a star that I am creating the shortest distance between me and that star, right? Doesn't have to be curved, it's straight, right? And I have a great distance to the most geographically understood star, like the North Star, Polaris, right?
It has a ground position. It has a position where when you sit underneath
we do triangulation
at your zenith. Is
now if I'm going to understand the time that's going to take me to get from point A to point B, I should probably take into consideration Euclidean space-time and the curvature of
you've taken an angle,
but I don't have to do that.
You're ignoring that.
It doesn't really matter because I can ignore that and I can figure out my position based on where I want to be and where I am in consideration.
About celestial navigation, which is where you take elevation angles to.
No. These are all triangles. These are actually triangles, and they are actually triangles when we measure them across Euclidean spacetime. But when we actually bend them, which actually happens.
Why are you bending it?
It takes.
What are you talking about?
Because
why are you bending it?
Because the Earth is a sphere.
No. It's measured and navigated flat. I've just explained this.
It is
an elevation angle requires a flat baseline.
It's measured and navigated flat. You are correct. No, you're not wrong about that. It is measured and navigated
to Flat Earth,
flat.
mate.
However,
no. Welcome to Flat Earth, bro. Good. Yeah, you're getting it.
I'm here with you. I'm here with you. I understand how navigation works.
Dude, that is.
I understand that.
Welcome to Flat Earth. It's measured and navigated flat. I agree. However, what do you mean? You've just conceded it's flat, mate.
Yeah,
welcome to Flat Earth.
No, I haven't conceded.
Just take a breath, mate. Take a breath and just relish this moment. Just let it sink in. Just let it sink in. It's flat. Just embrace this moment. It is measured and you've just admitted and conceded that it's measured and navigated that way.
It is measured and navigated that way, but it is wrong.
Yes, there's no but.
We know it's wrong when we do it, and we give. Hold on, when we navigate this way, we give a certain amount of error based on the curvature of the Earth.
I don't even want to argue with you now. I just want to level with you now, person to person, right? I don't even want this to be a debate about. Just sit and think logically for a moment, right, about what you've just said. And try and remove yourself from the preconceived notions that you have about what you think or thought Earth was. Just imagine this was about any other topic or subject. No,
listen,
stop.
I already did, and you're wrong. Just because we create triangles on a curved surface doesn't make it flat.
Just listen,
and it doesn't make it flat, and we know that, and we know that with the time it takes us to get there. No, no.
If it's measured flat, what is it? If it's measured flat, what is it? CW.
Okay, imagine. So imagine
just answer the question. Just answer the question.
If it's one word answer, it's a one word answer. If it's measured flat, what is it? CW. One word answer.
That's a loaded question.
It's measured flat. It's
admitted it was
wrong.
Flat.
Wrong.
It's a hypothetical question.
You've just measured it flat. It's not wrong. You've measured it. If you're saying that a measurement is not a measurement, then measurement means nothing. And you haven't measured a globe. You haven't measured anything.
He said it was measured that way.
We do this all the time.
Who cares? Who
cares? I don't know why.
You can't even measure it. You can't even measure the angle of a triangle. You can't even measure how long a line is. You've just admitted that measurement doesn't mean anything. You've conceded in one breath that measurement.
You can measure the angle of a triangle. Dude, and you can do it based on a flat map. You can do it based on a curved map. You can do it both.
You just conceded that something that was measured a certain way is in fact not that way because of some arbitrary reason that you're going to give it.
Imagine
the fact that it was measured that way.
For a second,
I don't need to imagine anything. I need you to concede
the point. Globe on a desk, right?
Okay. Why would I imagine that we've got a globe on a desk? Well, what's the
practical use of this? Imagine you and I are sitting here, and we see a globe on a desk. And we go, let's put a triangle on this globe. Do you think it will curve or not curve?
It will curve.
What?
Okay.
If you put a triangle on the globe, it will curve.
Some of its angles will be 180 degrees or not.
I haven't even. Are you talking to me or are you talking to someone else?
I'm talking to you.
Right. So let's go back to the first part that I didn't understand. You're saying that you're putting a triangle on a globe for whatever reason.
Between us. You and I are sitting across from each other. We have a globe. We have a circular, spherical object in front of us. And we go, okay, let's put a triangle on this object. And then we put a triangle. We put a triangle in which all sides are straight on top of the globe.
And how are you holding it?
Put it on the globe. And then you go, okay, well, the sum of the angles of the triangle, because I know things about triangles.
Yeah, but hang on, how are you holding this triangle on top of the globe?
You put, like, you draw a triangle on a piece of paper and you just push it onto the globe.
On what do you mean? Are you talking about it sitting on top of the globe? Like, you're not describing this very well.
So, okay.
Like,
so
I'm imagining a ball now.
Okay, all right. I'm sorry. No, I'm sorry. This is my fault.
Are you talking about superimposing a triangle onto the globe?
Yeah. So I'm talking about, like, we have a globe, you and me. We have a globe between us. It's a spherical globe. And then I draw a triangle on a piece of paper. And then we push it onto the globe. Now we know things about triangles.
It's not a triangle anymore.
We know things about triangles, so don't we?
They have to be straight.
What is the sum of the angles of triangles?
Who cares? Who cares? This isn't how we navigate or measure the Earth. Who cares?
It actually is how we navigate and
no, it isn't. When did you get a piece of paper and bend it? Or what are you talking about?
Actually, we use trigonometry.
We don't do that.
Every time
we don't do that.
No, actually, we do.
That's not how we. That's not how we navigate. No, it isn't.
That is how we navigate. No, it is. Yeah, no.
Citation, please. Show me where in celestial navigation we bend anything. I will wait here until you provide the citation.
We don't bend anything in celestial navigation
because it doesn't bend. It's flat. Again, welcome to Flat Earth, bro. I know it'll take you some time. It needs to digest. It's hard, but welcome. You are one of us.
By the way,
you are just being obfuscating for no reason, and
dude,
and everyone else
you just admitted and conceded. I'm following logically here. You've just conceded it's measured and navigated flat, but it's not because all of these other reasons. You're an idiot if you genuinely believe that. Sorry,
it's measured and navigated,
and that's not an argument. I'm attacking your argument because your logic is just ridiculous.
But in 2 dimensions, it's not. We all know that
it's measured and navigated flat. You just said it.
Is not as big as it looks like on the Mercator map. We all know that.
You just said it.
We all understand
projection. Said it's measured and navigated flat. Are you taking that back now? Are you going to be disingenuous and say that
and navigated flat, and it's navigated flat.
Welcome to Flat Earth, bro.
So
Welcome to Flat Earth.
Hold on.
Welcome to Flat Earth. No, there's no hold on.
Objects,
Welcome
which are
to
really, really far away, and they don't move that much.
It's over.
And so that's why we do
it's
that.
over, bro.
Dude,
you just admitted it was measured flat. It's
Hold
over.
on. Did a Glober just say it's measured and navigated?
I don't understand why you guys are doing this. Why are you doing this?
Well, welcome to Flat Earth, Glober.
Welcome. It's measured and navigated flat, he says. But, however, there's a reason why. But he admitted
there's actually a reason.
Measured flat is flat.
Dude, you not know why there's a reason why? Like, what do you?
Yeah, because there's no curvature.
Yeah, because it's flat.
There's no curve. That's why it's flat. Okay, great.
It's not measured flat. First of all, I never.
Well, actually, it's also observed that way.
You contradicted yourself. Why did you say initially that it was measured flat? Now you're saying it's not. Why are you doing this, man? Come on.
When you talk about geometry, when you talk about trigonometry.
Yeah, go ahead.
No, it's fine. You guys are obviously right. You win.
You said it was measured flat, and now you're saying it's not. Okay, when you talk about geometry and you put curved triangles on a sphere.
No, you don't. You don't care. I mean,
come on. Do you agree that you did say that initially? You said it was.
I did, and I understand. I understand what I meant by that, but I understand that you guys took it to mean something completely different than what I meant by it. But.
You mean we took your words for what they were and meant what they actually meant? My goodness, mate. Are you...
Man.
You must be trolling.
Win,
I don't
and
understand.
you guys... No, it's fine. You guys
Sorry,
win.
Mate. You must be trolling. I just don't understand.
I'm not trolling, dude. Like, I can talk to you if you want to listen.
Okay.
No, I'm going to join the conversation, but you've conceded the points that I was making. You've admitted and accepted that it's measured flat, navigated that way. But then you're trying to do this scumbaggy thing of saying, "Oh, that's not what I actually said or meant," or "It is measured and."
No, I mean, I could probably have a conversation with you about this, but it's not scumbaggy, nor is it what I meant.
It's disingenuous.
When I said that.
It's disingenuous.
It's not disingenuous. Okay, it's not. It's not though. It's not.
Oh.
Okay. So show how celestial navigation proves the globe without saying that the Earth is measured flat. Do not say the Earth is measured flat. Use celestial navigation to prove the Earth is a globe. Go ahead.
I don't think that you can use celestial navigation to prove that the Earth is flat or round. I don't think you can prove either claim with celestial navigation.
Okay, how about this? In celestial navigation, can you perform that without measuring the Earth as flat or without using a flat Earth? Go ahead.
I think this is, I don't know this, but I think if you thought the Earth was flat, celestial navigation would have much higher curvature to it. It would necessarily have that, and you would not be doing the most efficient thing. Doesn't mean that you don't get to your destination, but
okay. And just to be clear, you do not need a flat baseline, right?
No, I mean no, of course not. When you're triangulating your position between the thing and where you are. You have 2 points, right? You're assuming where the other point is. That's what triangulation is.
Okay. So in a triangle, there's 3 sides. Okay, now one.
No. We don't need to worry about that. We don't need to worry about the sides. We need to worry about the points. I'm at a point when we're talking about celestial navigation. Okay. I'm at a point. The star is at a point. The point where I want to be is at a point. Right, and then we triangulate that. We turn that into a triangle.
Yes, but the triangle has a baseline that's from your position to the GP of the star, and the other line of that angle is from your position to the star.
Yes.
Where's the bending happening? That angle requires 2 straight lines, bro. I can't believe you're even saying this shit. That angle from you to the
straight lines.
Listen,
yes, but it doesn't.
yes,
it
two
doesn't
straight lines.
work.
So it's flat.
It doesn't. No, it doesn't. It doesn't.
Bro, you're blowing my mind.
My point is that it doesn't work. Actually, it works. It works in practice. It works like when we're navigating
in reality.
Yes,
It works in reality. It works in reality.
You can see
it.
No, not to the degree. And you know, no. This is where I know you're trolling, because it works.
It works in reality. Now let's go to Fantasyland and talk about that. Go ahead, CW. You got the mic.
You're trolling. This is how I know you're trolling, man, because it doesn't work to the same degree. No, it doesn't work to the same degree as if you understand Euclidean geometry.
It works completely. That's how we've navigated for forever.
Said it works in practice.
No, it's not. It's not how we navigate now, and it's not how we navigated forever.
There are lots of people.
And navigation became way better once we understood Euclidean geometry. That's absolutely true.
So
that we were better at it once we understood the curvature of certain things. And
curvature of what things?
Including the Earth. I'm sorry.
Yeah, but
to say that.
But it doesn't curve. You've admitted that it's measured and navigated flat.
True.
It's
say that.
Today it's not measured and navigated flat, but it was at one point, and you can get. It's not. It's not.
Wait, when was it measured flat? Wait,
it's measured and navigated curve.
So it's just been gradually bending over time.
Wait, why? Okay, when was it measured flat? When was it measured flat? Go ahead.
Like
by
late
who?
1600s, probably.
Okay,
by
who
the
did it?
Indian Trading Company.
Indian Trading Company, and how did they measure it flat?
The East Indian Trading Company.
And this is
why.
And the East Indian Trading Company measured it flat. Doing what? Celestial navigation. Is that what they used?
Yes. Yes.
Okay. And they measured the Earth flat.
Mm-hmm.
Okay, so why are you arguing? Why are you? So you agree that the East Indian Trading Company measured the Earth as flat? Yes.
Yes. Yeah.
Okay, it's over. It's done. There's no going back now. It's over, bro.
I'm not going back. Why would I go back on that? That's absolutely what happened. Why?
Yeah, but it's over. The globe is dead now. The globe is dead. It's over.
Well, I don't understand why you would say that. That doesn't make any sense.
You just admitted it was. Holy shit, dude! You admitted that the Earth was measured flat.
Yes, I admitted that.
It's done. It's done. That is the death of the globe, right there. It's over forever.
Why would you say that? That doesn't make any sense to me.
Because you believe that the Earth is a globe, and what you just said immediately kills that idea. It is
just because people measured something. People measured something that wasn't true doesn't mean that it's not true. Like
okay,
what do you
lied? Then they were wrong.
No, they weren't lying. They were doing things that were pretty much accurate, but they weren't based on the true reality of the Earth. We now have the true reality of the Earth, and we do a much better job navigating because of it.
Celestial navigation.
Are you saying? Wait, hold on. Are you saying that we navigate worse or better or the same than we did in the 1700s?
I would say better.
Now that we have maps.
Okay. Sure. Now that we understand curvature, no,
it's got nothing to do with curvature.
No, you said it was measured flat. I don't know why you said that.
It doesn't matter. If it was in the 1700s, it doesn't matter. Do you think that we do it better now?
So were they
measurement.
Wrong then? Were they wrong?
Yeah, they were wrong. Yes, they were wrong.
Why did you say, oh my God.
Why did I say that they did what they did? I don't know, because I'm accurate and because I care about history. I don't. Why would I say people did what they actually did instead of lying about it? Well, I don't know, because
you should have said they measured it incorrectly as flat or something.
No, they measured it as flat. That's absolutely true. And
Okay,
it wasn't that devastating for society. If people still today measured the Earth as flat, it wouldn't be that devastating to society. They don't do that. They don't do that, but they could. But like that doesn't change my perception
you measure it
of
flat
history.
every time you do celestial navigation. If you jumped out on your boat right now and were doing celestial navigation, you're measuring and proving that the Earth is flat. I don't understand your issue with any of this.
Well, it's because you are taking into account the error that would exist in a curved globe. But I mean, yeah, okay.
You were wrong in the beginning. I don't know why you left that out.
I don't know why you think I left that out. I never left it out. I'm still here saying the same thing I always said.
And then you said they were wrong.
Yeah, they are wrong slightly.
So it's not true.
It doesn't make that much of a difference when you look at a giant fucking circle. Then it doesn't make that much of a difference whether it's flat or 2 degrees off. Like you can still get to the port, and you can still see the port that you're trying to get to.
Just think about how crazy this sounds, right? So if you were doing celestial navigation and you've got Polaris, right, which is at your azimuth, right? It's basically 1 degree above the horizon. And then you're doing the angle to that star, that angle between the horizon, level with the horizon, and to that star that's 1 degree above the horizon.
You know Columbus did that, right?
But hang on a second.
Did Columbus
the baseline
land
of
where
that
he
angle,
thought he was going to land based on celestial navigation?
Can I finish my point? The baseline of that angle, which is 2 straight lines. So the baseline, which goes to the GP of Polaris, right?
Yeah, it's wrong.
And then what? Hang on. You do that calculation, and you will still get to where you need to go, even if it's 1 degree above the horizon. Now you factor in the distance, because that's going to be 1 degree above the horizon, basically at the equator. So you're then navigating from there to the ground position of where the North Pole star is. But you've calculated it flat the whole way, and you're saying that you'll only be off by a few degrees on a ball. I don't think so.
With the Mayflower ending up at a different country, and you do understand this. Celestial navigation ended up with the Mayflower way off where it thought it was.
Fine. People can absolutely make incorrect calculations.
Yeah,
celestial navigation requires you to be precise in what you're doing.
Right, and we do understand that they were using very precise, and you can look at the navigation maps for the Mayflower. You can understand that they were using very precise celestial navigation understandings, and they ended up very far south of where they wanted to end up. Why do you think that is?
Well, I have no idea. I don't know the story of the Mayflower. I'll have to look into that. That's not really relevant. That's not really relevant. Somebody stuffs up their navigation doesn't mean that the process is wrong, and it certainly doesn't change the fact that it's still measured and navigated.
The math is absolutely wrong when you pretend that the Earth is flat versus it's round, and you end up a few degrees off, and then you end up going to a different country, which happened multiple times, all the time. And so you're acting like historically we were just ending up where we wanted to end up. That's not historically what happened. Our celestial navigation was wrong when we were using and navigating. We still do by a flat Earth model, but we don't do that anymore. And the reason we don't do that anymore is because we have GPS, and the GPS relies on satellites that are orbiting the round Earth that we all know we live on.
CW,
sorry, man.
When was the flat Earth model used for navigation? What are you talking about?
The flat Earth was never used, ever.
Wasn't that what you just said?
No. What we're talking about is triangles. We're talking about straight lines and triangles. I'm sorry that you've had a hard time keeping up with this conversation. I apologize that I didn't make it that simple for you. That's what we were talking about.
You missed the part where he admitted and conceded that it's measured and navigated flat, and now is trying everything he can to.
It is measured and navigated flat by old and outdated methods of navigation.
Like what? Like which
the
one?
word?
Celestial navigation is old and outdated, and celestial navigation has a very small error method or error. What's the word?
I don't think you know what you're talking about.
No, I do know what I'm talking about. I sail ships all the fucking time. God damn it.
You do know how to do celestial navigation?
I know how to do it. I don't do it because it's not the way that we do navigation nowadays. We do it via GPS. And GPS,
you say you know how to do it, right?
GPS engages with the round Earth, but as far as like understanding celestial navigation, yes, I do understand how it was done. It's not done anymore. And when it was done, it was really, really, really fucking wrong. A lot of times. And so anyone going, oh well, we got it totally right via celestial navigation. No. Look at where Columbus landed versus where he wanted to land. I mean, we know how people ended up in different places than they wanted to end up via celestial navigation. We have tons of records of this. They thought they were going to end up somewhere on some latitude, and they were very, very wrong on the latitude.
They weren't wrong in the latitude. They weren't wrong in the latitude. They were wrong in the longitude. Know why that's the case? Columbus didn't get the wrong latitude. Well, he got the wrong.
Literally both was because of the curvature of the Earth, and it's explained very easily by the curvature of the Earth. Explained.
Columbus wasn't a flat earther, buddy. And no, that has nothing to do with the shape of the Earth.
Columbus was not a flat earther. Columbus was a round earther, and Columbus absolutely fucked up on his celestial navigation because it wasn't accurate enough.
Because he might have been factoring in a ball that doesn't exist, perhaps.
We do not.
No.
Currently now, how we navigate and where we navigate boats is via GPS and via buoys.
You're just making shit up on the fly.
No, I'm not. I'm literally not making shit up on the fly. You have no idea what you're talking about.
Let me correct you. Before the 1700s, when Columbus was navigating, there were no clocks that you could carry with you to keep accurate time. So you couldn't solve for your longitude, but you could still solve for your latitude. Columbus was in the right latitude. He was simply not on the right longitude yet because he was still half the way through. So he was following the same latitude line, and he got the correct latitude line, but he had no way to know the longitude that he was. That's why he fucked up.
He ended up in the West Indies, and he thought he was in the fucking Americas.
Yeah,
he was
same
wrong.
latitude, but he was right in the latitude. The latitude wasn't the problem. The problem was the longitude, and the issue has nothing to do with the shape of the Earth. It had to do with him not having a clock.
It had to do with the shape of the Earth. It absolutely had to do with the shape of the Earth.
Why do you think?
It had nothing to do with the clock. What are you talking about? The clock has everything to do with longitude and nothing to do with latitude. Where's the clock coming?
That's what I said.
Yeah,
I just told you. Yeah, without time,
where does the clock come into play?
Because without time, you can't solve for your longitude. In India and America,
who cares what time zone? Who cares what time zone you're in? Turns out that Columbus ended up drifting a little bit south of where he wanted to be. And he did that because he was navigating celestially, which is what people did.
In the 1600s, it was very easy to get your latitude right.
Great. What about your longitude?
And that has nothing to do with the you couldn't solve for longitude in the 1600s.
Yeah, no, yeah, it sucked. Celestial navigating, it sucked. And it didn't work out. And this other guy is like, oh, we still do this today. No, we don't. We use GPS. And GPS absolutely gives you an absolute point on the Earth. And you use longitude and latitude to figure your position out. This is the dumbest fucking conversation I've ever been a part of in my entire life. I don't even know what we're doing.
Celestial navigation is still used. There are boat races where you don't have access to GPS.
It's used when there is no GPS. Yes, absolutely.
Yeah, it's also used as a hobby.
Used. What is it used for? It's used to get you to the nearest port or the nearest coastline. When
it tells you where you are within a couple of miles.
When longitude doesn't matter and latitude really matters, because latitude matters a lot more. Correct?
No, it does. No, it depends what you're trying to do. If you're trying to travel north and south, for example, then you need the longitude much more than you need your latitude. It really depends on what you're doing. And celestial navigation
if you're that close to the coast, but if you're in the middle of the ocean, you want to move either west or east. Correct?
Or north or south, depends on where you're trying to go and where you are.
No, if you're in the middle of the Pacific or the Atlantic Ocean, you do not want to move north or south. You want to move west or east.
Only if your target is directly east or west of you. It might not be. It might be northeastwards. It depends on where you're going.
If you're looking for a coast, period, then you want to move west or east.
Yeah, people don't.
And you know that's the case. You know that's the case.
People don't simply follow a line of latitude until they go to coastline, and then they move north and south. That's simply not what people do.
No, I understand that. People try to use like bird paths or whatever the fuck. Flight of the bird. But that doesn't matter. If you're lost at sea, you go either west or east. You don't go fucking north. You don't do that.
You're never lost at sea. You're not doing navigation when you're lost. That's not what it's for.
Yeah, that's true.
All right, so
for navigation, you'll use nautical almanacs, which
nautical almanacs also agree that the Earth is round.
They don't agree anything like that. What are you talking about?
Yes, they do.
Citation.
How do they agree that anything's round? How do they agree the shape of
those straight triangles that you're using on navigation almanacs are actually curved triangles in real Earth.
The almanac doesn't give you triangles. You could be talking about the side reduction tables, not the almanac. I mean, there are very good arguments available for you to use. You're using very bad ones. The almanac you use for the geographical position of the stars, not for real math that takes into account the shape of the Earth, which is where the side reduction tables come into play.
Oh, fine. Okay, fine. No, you guys got it. You got it. Okay.
So just to be clear, the curved triangles,
they're just like a part of the Earth, and we do that all the time.
Okay, and so if I draw a triangle that has curved lines, each side of the triangle is curved, and I make the angles wide enough, the triangle will look identical to a circle, pretty much.
Okay.
What? I mean,
when's that ever done in navigation?
Yeah, but it doesn't. I'm saying, if you believe that triangles can be created using curved lines.
Okay, think about this for just an absolute second, please.
Yeah.
Take a triangle, put it on a balloon. How big is the triangle? You draw a triangle on a piece of paper. You put it on a balloon, right? The bigger the triangle, the more curved the triangle becomes. It's still a triangle. still got 180 degrees angles and 3 sides. Right?
And doesn't have
and you put it,
degrees
you put it, yeah, I know exactly. You put it on a balloon and you curve it, and then all of a sudden the angles become bigger, right?
So if the
Because
so the
it's
angles,
not a triangle.
the angles are curved.
It's still a triangle. No, it still has.
It's not a
3
triangle
angles.
once it doesn't have 3 straight lines anymore.
It's all we call a spherical triangle.
Yes, yes, it is. No, yes,
No,
it
it's
is.
It's not a triangle. It's not a
Wait,
triangle.
hold on.
Once it's not,
What
a
does
triangle is
triangle
3 straight
mean?
lines.
Hold on, listen. Triangle means 3 angles.
Spherical,
3
triangle.
angles is a
There are
triangle.
2 terms.
Like that's what that
What does
means.
angle mean?
Hold on.
What does
Hold
angle
on.
mean?
We gotta understand what a triangle is.
What does angle mean? You're talking
Angle
about what
means-
triangle means? 3 angles. What does angle
flat.
mean?
Why does my girl have
Angle
a
means
flat
the
arm?
side
It's
meets the other
round.
side. There's still 2 sides meeting. There's an angle. You put
They're
it
2
on
straight lines. An angle
This
is
is
2
hilarious.
straight lines meeting.
Oh my god, this is hilarious.
We're
Keep
learning
going.
about Euclidean space-time right now.
The Earth is flat. Why does my girl have a flat, round ass?
We heard
It doesn't matter if the Earth is flat. If I put a triangle
Interrupting
on paper on a
Joseph,
balloon,
if one of you
on a
guys tell me
balloon.
which idiot that is, please.
Shivers, I think the guy that keeps saying my girlfriend's ass is round.
Who was it? Sorry.
I don't know. I think it was Shivers. I don't know. That Shivers was deflecting while it was happening. I'd defend
right.
yourself, Shivers, if it wasn't you.
All right, on we go. If it happens again, we'll deal with it. Go ahead.
Okay, so if I draw a triangle, 3 angles, it's called a triangle. 3 angles.
Yeah, what's an angle?
It's kind of how we define it. There's 3 angles, right? They equal
so
180 degrees. And
Let's
then
do
I
some Socratic reasoning then. Are we going to agree on the definition of an angle
onto
first?
a
before we talk
round
about triangle?
surface. All of a sudden, no, we still have a triangle. All of a sudden, I push that flat triangle onto a sphere.
He's avoiding the question.
The angles are bigger than 180 degrees.
He's just
But it's still
steamrolling
a
on like you didn't
triangle.
ask him a direct question to define an angle.
What's an angle, mate?
An angle is the relationship between two. I don't want to say 2 lines. 2.
You don't want to say what the definition of an angle.
lines.
Yeah, well,
You're going to define an angle without saying 2 lines.
Two vertexes intersecting would be the angle.
Vertexes intersecting.
Vertex are points. Points don't intersect.
Are the vertexes straight or curved? Are the vertexes straight or curved?
They're equidistant from their center.
They're straight? All right, there it is.
That doesn't make any sense. Yeah. Vertices are points.
Oh, so they're not even... So you're not using a line then for this?
No. What I mean is rays. Like 2 rays intersecting would create an angle.
Are the rays straight or
I don't
curved?
know. I mean, lines are infinite in either direction. So
Are the rays straight or curved? Are the rays straight or curved?
Rays are always straight. Lines are always straight.
Okay, so you need 2 straight lines.
And curved lines
2
don't
straight
exist.
lines intersect, right?
Okay.
And they create an angle, right?
Yeah, and then you get
Angle
3
is-
of those. So all 3 of those would require straight lines. So you get all 3 of those, and you've got your triangle. So you've got lots of straight lines.
Right.
Now
and then
explain to
and
me
you
how
push
they're
it,
curved.
And then you push it onto a circle, and then all
So
of
then
a
you
sudden,
make it from being a triangle to not being a triangle anymore.
No, it's still a triangle.
But the lines aren't straight.
The angles
So
on
they're
the
not angles.
It doesn't matter if the lines are straight. They're
Oh,
still
okay.
3
Yeah,
angles.
sorry. Yeah, it doesn't matter.
This is just semantics, though. It's just between triangle and spherical triangle. Somebody just needs to stipulate that there are 2 different things, and then we're fine, right?
Well, it's called
Well, no, because
space-time.
he's it's more specific because when he describes the triangle on the sphere, he also mentions the angle, and then like we talked about earlier, the angle requires 2 straight lines, so you can't. Yeah, you can talk about
straight. Those lines
so
are straight.
let me ask this: could I?
Those lines are straight across the sphere. They're straight. They're still straight, but they're curved.
What?
And I understand how that's like
law of identity violation. Law of identity.
There's no violation of the law of ideality.
Yeah, it is. It's either curved or straight.
But they're curved,
Yeah,
but the literal definition of straight is not curved. Come on.
Yeah, exactly. Either you can take an angle from a curve, or it's got to be a straight.
Imagine the Mercator map, right? Like, and I go from New York to Los Angeles.
Excuse me for
I
a
draw a
minute.
straight line.
Linda,
Linda, waffled enough. Somebody else is going to say. Go ahead, Flatman. Go ahead.
Sorry about that, but they're literally trolling on such another level that they're literally saying something to this effect: space is fake, but I still think we could go to Mars and the Moon.
What? What are we discussing? We're discussing the difference in geometry between Euclidean and spherical or non-Euclidean geometry.
They're talking about
so left field, man.
So it's like saying, I don't believe in space, but I think we can go to Mars and the Moon. Like, he's trolling on another level.
Yeah, let's get back. Okay, tell us about the curved triangle. Go ahead. Sorry, we don't mean to distract you.
So a great circle route on a sphere is a line that is stuck to the surface necessarily and does not deviate left or right. That's what it is. So if you set off in any direction on a sphere, like do it on a basketball so we don't all blow our brains apart, on a basketball, if you start drawing a line in any direction, it will necessarily become a great circle route and bump back into itself unless you deviate left or right. So those, if you imagine those, you go, well, they're straight as in they do not deviate left or right. Can I make 3 points with that across the surface of a basketball? Obviously, also the answer must be yes, right? Because we know balls that are like beach balls are made out of triangular-ish sections, but they're not triangles, are they? Right? It's got big ones down near its equator, and then there's the beach ball comes up to that little nib at the poles. That is not a triangle, but it is 3 lines connected, and those 3 lines do not deviate left and right. And we call that thing a spherical triangle. It's not a triangle, obviously, because it doesn't follow Euclid's law. And to just say, oh, it's a triangle is lying or not really lying. It's just being expedient or, not precise.
Okay, CW, do you agree with him that they're not? He describes it as spherical triangles, not let's just say colloquially, they're not triangles. Euclidean, whatever. Yeah.
Yeah, they're not Euclidean. They're a non-Euclidean kind of triangle.
Okay.
It's just you still call it a triangle because it's got 3 points and they're still connected by a line of sorts, a straight line of sorts, if you're only paying attention to the surface of a ball, maybe because you're a beach ball manufacturer, right? And you want to know how big to cut each of those, identical strips, you'd probably use some spherical trig in that, right?
Okay, CW, do you agree with him that they're not triangles?
CW is muted.
Oh, okay. Sorry about that.
I'll take him off. He's just really waffly and he never stops. Here,
180 degrees on a flat plane.
Look at that.
But
you see that?
But all
still going.
The entire time, not knowing he was muted, he's completely out of pocket. I'm just going to leave him like that. It's just
he was mid-sentence.
It hinders.
He didn't know he was muted, though. To be fair,
it's like muting Gene or DMark.
Yes.
All right.
Do you reckon we could test this in reality? By which I was saying, could you, like a series of ways you could do it? Can you determine due north-south, like perfect north-south? Is that possible for a human to, from a point tell you which way due north is? And then from that, can you derive east and west? And if you can do that, couldn't you test this idea of a spherical triangle by changing latitude and seeing the rate at which it changed latitude? It'd require very precise measuring, but instead of going up and down, which is what everybody does, lasers over lakes, you're trying to see does left and right deviate, essentially. It's a good test because the globe demands it.
Well, if you go along with celestial navigation, you can pick up side reduction tables and get 3 points on the surface and see what angles the side reduction tables give you for the azimuths. And then you're going to get the three angles between the 3 points. If that's a flat triangle, you're going to get 180 degrees when you add them up. If that's a circle triangle, you're going to get more than 180 degrees.
That's a perfect way to do it. And then you just go, well, I'll choose stars that are in my local area, so I do trust where they are.
Wait,
that'd be perfect because the stars will have azimuths. Sorry, the points.
I got a question though. So when you mention the word angle, and you're talking about a spherical triangle, are you saying that there's an angle that you're measuring, and even though there's two straight lines, I'm assuming
I never agreed to the definition of straight lines. I would say, let's put it this way: you're trying to draw a football, right? Like an American gridiron ball, right? And it's two curves, but then there's 2 points at the end, right? They're curved lines. But are you saying it would be impossible for me to measure, approximate, or calculate the angle at which they intersect at the tippies? Are you saying it's impossible? Humans cannot derive an angle from a line that comes from a curve? Is that the suggestion here?
The curved line of measuring an angle using curved lines.
Yes.
Are
you saying it's not possible?
I haven't seen it done. I don't know. Okay. I honestly,
if that was possible, what then? What would that mean?
Well,
why are you suspecting
I'd be open
that
to
humans
it.
Can do this?
I'd be open to it. Show me. I'd like to see it.
So if you have two functions plotted or two curves in something like GeoGebra or any website that you can simply plot curves, and at some point they intersect each other. So the two curves meet at a point. If you zoom in into that point, the more you zoom in, the more straight those lines get. So if you zoom in sufficiently,
Sorry, go ahead. I didn't mean to. Sorry,
that's just geometry. You know that, right?
If you zoom in sufficiently, you can literally put a protractor on your screen and read the angle in which they intersect. So that's the angle of their intersection. That's not the angle of the entire line, obviously, because they're curved. If you...
Sorry, I didn't mean to laugh. Sorry. Go ahead. Sorry.
I think I missed the punchline, but go ahead.
No. I'm letting you finish. I just realized something. Go ahead.
Well, then just say it. Other than doing that, that's just juvenile to interrupt somebody with laughter of a joke that's in your head. Like, just tell us the joke.
Okay. My when you say you zoom in so far, you zoom in, and eventually, if you zoom in far enough, the line becomes more straight.
Yes.
I just laughed because that actually. Why would you need to do that if you could just?
Why did you laugh?
Because you need the straight lines.
Right. And a line is useful as a straight line the more it approximates. Like, the closer it gets to a straight line, the more useful it is. So, right? Where was the joke? You were laughing. I still don't get the punchline. Can you share it with us?
Because I was asking you to show me measuring an angle using curved lines. And you're telling me, actually what we do is we zoom in on the curved line so much that now it's straight and now we can measure the angle. Yes. That is hilarious. Yeah,
you're just repeating it, but laughing while repeating.
I know it's just funny to me.
It's a good repetition, though. I will give you that. That was a good steal, man. Wouldn't you say, Bacon?
I just think it's hilarious. I don't know. Go ahead.
Yeah, wouldn't that be the angle in which those lines are meeting? So, for example,
when they're straight and when you zoom in, after you zoom in and they're straight, I agree.
But I'm not changing the lines; they're still the exact same lines. So if you agree that that's the angle in which they intersect when you zoom in, then once you zoom out, the angle won't change because you already measured it, right?
So when you zoom in, they're straight, and when you zoom out, they're curved. Is that what you're saying?
That's not what I'm saying.
Okay, so when you zoom in, why do you need them to be straight?
I'm saying if you zoom in enough, you can read off of a protractor on your screen. Like, you can literally
that would be a way to measure it.
Okay, so you don't need them to be straight.
No, this is just a visual way for you to understand what does the angle between two curved lines mean. It's simply the angle in which they intersect. And one way you can notice that there's actually an angle in which they intersect, and that's measurable, is by zooming into the intersection. At a certain point, it becomes clear that there is an angle there, right? So when you're zoom out,
why do you need to zoom in though? Why do you need to zoom in?
Because what matters is the angle at a point of the intersection. So if you zoom out, you have the rest of the line, and the rest of the line doesn't matter. So let's say the rest of the line is just a distraction from what the actual angle is. Once you zoom in enough, then you focus simply on the intersection part of it, and that's all you can see is simply how they're intersecting. So when you measure the angle,
that's not an angle.
You can.
What is
why
it?
can't you just go ahead? Sorry, go ahead.
If it's not an angle now, what is it?
You can literally put a protractor on the screen.
It's curved lines intersecting. You can't get an angle from that.
Well, you can. You just factually can.
You can literally say. You can literally.
What do you mean you
just
No, hang on. Let's go back to our Socratic method, right, where we were agreeing terms. Before, I thought we were all in agreement that an angle is two straight lines intersecting.
No, it's the point at intersection, though. The point that Bacon's trying to get at is it's the point of intersection, which means there is no length to an angle. An angle has no length or breadth or height or depth. It is just a sort of measurement of a full circle, a comparison of any line and another line in comparison to it in a full circle, right? A portion of that circle of 360 degrees. And what Bacon is giving is a way to measure it by making it closer to straight. But an angle definitionally doesn't care about what happens after that exact point that you're asking the question from. If you're saying what's the angle at point A, it doesn't care what the line's doing in the next, like pick a distance, and you couldn't get small enough because an angle is definitionally a point, right? So it cannot care about the otherwise shape of the line because it is agnostic to that, because that's outside what it is, which is a point. Do you get what I'm saying?
Give an example.
That's actually
just
Euclidean geometry. A point is that has no parts. The line is one dimensional. The point is no dimensional.
Exactly. That's my point. My point is, how could you care about the rest of the line? Here's like.
I mean, the rest of the line doesn't really matter,
but
you can only have an angle if you've got two straight lines intersecting. If they go from being straight to something else, that's fine. But where the two straight lines intersect, that's where you get your angle. You can't get an angle if those lines are not straight, though.
Search the term in geometry. Sorry, and then I'll pass to you, Bacon. Search the term in geometry normal. So just plug into Google normal geometry, and what it will describe is a vertical point, or a point that is leaving a curved line at perpendicular to that line. That must require an angle. The term normal means if I have a worm, a wiggly worm, or a basketball or something, and any point at that surface, I go, this is straight up off that surface. That requires that there's an angle because it's part of the thing, and geometry has it as a term, and it is normal. It's also what tangents are. Tangents are that line at that point, the way it's going at that point. So you can take an angle between two tangents, right? Because they're straight lines. There you go. Done. Sorry, Bacon.
So
there you go.
No, that was good example. But I posted on the chat a more physical thing. So if you aim a laser beam at a spherical mirror and you turn on the beam, there's a certain direction that the laser is gonna be reflected to, and the direction in which the laser beam gets reflected depends on the angle in which the laser beam hits the mirror. But the surface of the mirror is curved, and that doesn't prevent the law of reflection to continuing to apply. So the law of reflection is still the same. It depends on the angle in which the laser beam hits the surface of the mirror. Now, if you say no, but that mirror has a curved surface, so there's no angle, then that would mean there's no answer to where the laser beam shoots off after it gets reflected. But obviously there's an answer for that, and it's really easy to calculate. All you gotta do is to figure out what's the normal vector of the sphere. So what's the vector that is perpendicular to the surface of the sphere? And again, we have an angle between a line, which is the normal vector, and the surface of the sphere, which is a curved surface. So now, if you don't agree that that's possible, then you're saying there's no answer for this challenge. But if you give this challenge to a high school student, he'll give you the answer, and you can actually test this in real life.
Well, they're telling us the truth, aren't they, Bacon? They're saying, I can't do that, which is true. I wouldn't know how to calculate that. To calculate normal, I'd be pretty confident that I could know what to do once I had normal. And again, normal's just at a single point.
For a sphere, the normal is very easy. It's simply a vector that connects that point on the surface and the center. So you extend
it's just
the
going
line.
to be a radial, isn't it?
Exactly. For a sphere, that's easy, but for other curves, you've got to work out the derivative of the function of the curve.
Of course, because you do this in computer stuff, right? You go, I'll paint all the normals this color, and they paint all the normals. I saw some guy doing that, and it's just make all of the outside from this side look like that.
Yeah, like when you're doing 3D rendering, for example, you work with the normals of any geometrical shape. Oh, well, I mean, in that case, then you don't actually have curves because. Never mind. I think I'm going too deep into this.
You
but
just
the point
use
is,
the cross product, and you get the normal for any surface if you have two vectors that are on the plane.
Yeah, essentially this argument should have been dead from the point where it's like if a tangent exists, which it must for so many things, then you can make a line from a curve. And so then if you're saying, well, you can't get an angle from a straight line, it's like, well, it doesn't matter. If you can make straight lines from curves, then it's just a dead in the water point. It's just saying, well, I don't know how to do that bit of maths, and so I can't get meaningful results. Well done. Maybe try doing the opposite.
I think another good example is...
I hate that argument, honestly. Yeah, it is a straight line if you say it's a tangent.
Yeah.
Oh, I mean, another
good on you, by the way, Heretic.
Well, it's just not an argument. A tangent is a straight line. I just don't really think it's a good way to go.
Yeah, I'm with you. Sorry, Bacon, I spoke over you again.
I think it would just be repetitive. Because the same way you get this issue with curved mirrors, you get this with lenses, because lenses are curved. And Snell's law applies to them. So you gotta get the angle between the light ray and the surface of the lens that is curved. How do you do that? Well, people that do math on lenses have no issue with that. They don't say, "Oh, that's a curve. I can't proceed." There's no angle to a curve. They simply do.
And I think it's a worrying one to say out loud, to say I can't get an angle from a curve. It's like, well, then how do you disprove the globe if you don't know how to do a thing that is a standard thing in geometry, and that is the thing that would be required for your measurements of the globe to make sense, right? Being able to derive and measure and test angles from what could be a curved surface in order to prove that it's not. To say, well, I don't know how to do maths if it involves curves is a dangerous argument to play. So I get why Heretic challenges it. You challenge it.
Well, the reason I challenge it is because it's such an easy rebuttal for you guys. You can just say it's a tangent. There you go. There's your straight line. Then we can challenge, okay, do you have a tangent point? Can you demonstrate that in reality? But nonetheless, just saying that you have to use a curve, that you can't invoke a straight line at all, I think that bit's erroneous. Sorry.
Yeah, no, I'm with you. Good on you for saying it.
Seems obvious.
Yeah.
Okay, so
I can tell what straight up from a curve looks like, from a ball or a pool noodle.
Yeah, I think the other guy would say something.
I was gonna say, so just to be clear, the way you get an angle from two curved lines is you zoom in on the point of intersection, then you take out your protractor, and the reason you zoom in is not to make them straight. You don't need them to be straight. So you're just zooming in so that you can use your protractor, right?
How you choose to measure an angle is completely up to you. Bacon gave you one super, super easy way to do it because he assumes you're sitting at your computer screen. That is not the NASA way of measuring angles. If you want to learn how to do it, I would suggest pick the easiest method, which is what Bacon gave you. But there are probably far trickier methods because the angles exist. The angles are there, out there in reality. The question is that you're trying to debate is I can't measure them. And that's a dumb argument to make.
No, I'm asking you for a demonstration. So
I don't need to demonstrate that angles exist.
No,
you can't measure them.
No,
I can. I'll just use Bacon's method.
No, you said that you can get an angle from two curved lines. So I'm asking you. The reason I'm asking about this protractor is because when I'm zooming in on this intersection between two curved lines, the reason I'm zooming in is not to make them look straight. The reason I'm zooming in is to use the protractor. So That's one way that you believe that you can get an angle between two curved lines. So do you agree with that so far? Are you with me so far with that?
You're the one who's missing it. Like here's how confident I am. You can take an angle. Of course, yeah.
Do you agree that you can get using?
True.
I'm just asking yes or no. Do you agree that when you zoom in on two curved lines, I can use a protractor to get an angle between two curved lines when I zoom in? And the reason I'm zooming in is not to make them straight, because I don't need them to be straight. I just need to zoom in to use the protractor, right? Correct?
No, the way you said that was dumb. I didn't.
Okay,
I didn't
then you need them to be straight. You need them to be straight. Then
Can I tell them how you do it?
Sure.
All right, you get the functions for both the curves, and there's a mathematical function to any kind of regular curve, and then you take the first derivative of each function, and you get the intersection point of the two things. The first derivative of each function will give you its instantaneous slope. And then you take that first derivative of each and you plug in the number of the intersection, and there's why you'll find the instantaneous slope of the first curve and the instantaneous slope of the second curve. And from those instantaneous slopes, you can find the angle between them. That's how we do it.
So once you find the instantaneous slope, you get the angle using what?
The arctan of the slope of each, and then you get the difference between the arctan of the slope of each, and that gives you the angle.
Okay. So you take the arctan of them. Okay, I got you. Okay, so it's not even you don't even need a protractor then. I'm assuming.
As Axel's already explained, the protract was just one example of how you do it.
Okay, got it.
I can do it. I can sometimes just do it from definition. Like here's one that we should all agree with. Do we know the intersection, the angle at intersection between lines of longitude and lines of latitude? And we do, don't we? Straight away, all of us off the top of our heads, unless we're morons, should say 90 degrees because they are north, south, and east, west, and north, south, and east, west are 90 degrees, definitionally. So sometimes you just go into your head and go, all the intersection between that curved line, because for everybody in both model and not model must have circular lines of latitude because they meet up with one another again, right? So those are curved lines. Now, the lines of longitude don't deviate left or right as they go across the surface of whatever we live on, but we know one of them's a curved line. So if it's impossible to do it with two curved lines, like this is halfway there, and we know that they meet at 90 degrees, they have to, because that's how the world works. But you still can't do it. You're still stuck with protractor.
No, I'm not stuck.
You're doing your side some damage
stuck.
Is all I'm trying to tell you.
I'm not stuck at all. I'm listening. I'm listening to what you're saying. So you get 90 degrees using longitude and latitude.
Well, one of them's a curved line. It's got to be. It's got to be a circle, right? A line of latitude has to be a circle.
On
the question is where the lines
model?
of longitudes are. Nope, on
whatever
any
model, unless
in the world, in reality.
Unless you teleport.
Yeah, the sun doesn't exist sometimes because the sun goes across those lines of latitude.
I think the issue is
you can do coordinates on a basketball surface with latitude and longitude. It's just a coordinate system.
Right, but lines of longitude, regardless of who you are in whichever model, because it's reality, has lines of longitude and they must be circular. They have to be circular. In the flat Earth model too, because they all circle Polaris or Sigma Octantis, tricks, but they all circle the south. Right, and so if you're going around in a circle and the sun's coming back to the same point each day on some of these lines of latitude, then it must be a circle. Are you guys really going to try and debate whether lines of latitude are a circle? Go on, give him. What shape are
flat
they?
Earth model?
I mean, lines of latitude is what I'm talking about. Do they or do they not come back to where they started?
Okay, I see what you mean. The only issue I have is...
It's a direct question.
Yeah.
Do lines of latitude come back to where they started? Okay, well done. So what is that?
The only
what
issue,
shape allows that to happen?
The only issue I have is when you say the word, or when you said the phrase flat Earth model. But
I don't think
there is
in that either. It's
No,
like
but
it doesn't matter.
there is no flat Earth model, is what I'm telling
I know, it's broken because the lines of latitude get fucked south of the equator. They're already fucked before the equator.
Well, no, but the size of the Earth is
south of the
unknown.
equator.
Yeah,
It doesn't matter how big a circle is something you can tell.
And the shape, flat's not a shape either. So now it becomes even more complicated.
But you're just running from the point. The point is lines of latitude meet where they started. They have no beginning and end. Nor do they have any vertices. What shape does that?
Where they started. Oh, sorry. I see what you mean. Like if they meet where they started. In other words, they can only do that if it's curved. I see what.
They have no corners, do they?
I get
lines of latitude have no corner. We can get there, man. We can do this. Squares loop too, yeah. Like they can be funny shaped, but I mean, circle's an easy way to put it, and all of the maths around them is a circle.
But unless they have corners, then they're gonna be curved. They can't loop without having corners or curves.
So that means, wait. Oh, but no, because this is like the thing about it is if there is no flat Earth model, then the only I don't know, but I agree with you that if it ends up where it started, I agree that sounds like it would be it would have to be curved in that scenario. Yeah.
Yes. So
I agree with you.
If lines of latitude are curved, they must be curved. Then how can we know the intersection angle between that curved line, which is a line of longitude, and the straight line, which is the line north-south? Sorry, latitude and line north-south, because latitude will always be going due east and west at any point, right? And we know what north is, which is perpendicular to those things. But north is a straight line in this one, for argument's sake. I mean, obviously they're all circles as well, but that's where the argument begins. So we can take an angle. Are you now happy that humans can take an angle from the intersection of lines, regardless of whether they're curved or not?
I need a demonstration.
Reality. I'm like, it's geometry, man. This is.
Can you post one? I just want to. I'll take a look. Just post one.
Google the word normal.
Okay.
That a north and south line is perpendicular to an east and west line at the same point. Do you understand it?
North and south is perpendicular to east and west. Sure.
Right. And so the east and west lines are part of a longitude line, which, as you conceded, has to be curved. So now we have a curved line.
You're talking about a globe.
No.
Not on a flat Earth, because there is no flat Earth model.
It doesn't matter. They loop. They have to curve somewhere.
Why?
Because if you follow a latitude line, you start at the same point where you end up in the same point you started. Like latitude
on what model?
On whatever model. Latitude 180 east is the same as 180 east is the same as 180 west.
So if I have a model that, sorry, go ahead.
Can I ask the gentleman describing curved lines? Are there also straight corners?
Straight corners. What does that mean? Just corners, like a square.
Exactly, a curved line.
What?
It's like you're describing a straight corner, man.
What? Are you asking me, or who are you asking?
Just continue talking about your curved lines. It's so interesting listening to you, Globers.
They were trying to give me an example of how you can get an angle using two curved lines. So I'm gonna Google the word normal and see what happens.
Yeah, normal vector. Google normal vector.
Normal vector. Sorry, my bad.
No problem. By the way, were you one of the guys saying that we navigate the Earth as if it's flat?
That was CW, actually. Oh no, he said sorry, my mistake. CW said the Earth was measured flat. My bad. I think someone else was talking about.
Bullshit.
Yeah. He did say. I don't know why he said that, but he
That
did
you don't
say
care
it.
about your longitude if you're in the middle of the Pacific, the Atlantic. Doesn't make any sense.
And when you're measuring, when you're getting, or sorry, when you are physically measuring longitude and latitude in reality, are you using the normal vector when you're like physically measuring the angle?
The normal would be your vertical line. So if you're taking a zenith angle, for
Okay.
example, to get your longitude or latitude, then I would say yes.
Okay, and you're using the, I'm assuming a sextant, right?
Sextant, theodolite, astrolabe,
Okay.
telescope, you name it.
And all of those have curved, like one of the lines in each of those devices is curved, right?
No.
No. Okay. So which one has the, where are you getting the curve?
What do you mean getting the curve? We're
'Cause-
simply measuring angles.
Because you're, yeah, you're measuring the angle, but you're using curved lines, right?
I'm not using curved lines or the angle.
So you're using
I'm using
straight
two lines of
lines?
sight. Yeah, one line of sight to the star, one line of sight to the horizon if you're dealing with a sextant.
Okay, how about let's talk about the one where you're using the curved lines. Where is the line of sight that's curved there? Or what, where is the curved line of sight there?
I don't think anyone is saying we're using a curved line of sight.
Okay, so you're using straight lines.
Yeah.
Okay, so they're straight. So I don't know why do I need this normal vector then? Why can't I just use straight lines?
The normal vector was an example where there's an angle between a curve and a straight line. A normal vector is by definition that it's a vector that is orthogonal to a surface, and that applies to curved surfaces as well. And orthogonal is simply the same thing as perpendicular, but more generalized.
When you're doing this angle measurement in real life, you're using a straight line.
Two straight lines.
Oh, well then why can't you, how about this? Can you think of an example in real life where you're physically measuring an angle using two straight lines, like in physical reality?
Two straight lines?
I'm sorry, two curved lines. Sorry, my bad. Can you think of an example in real life where you're using two curved lines to measure an angle in physical reality?
Let's say you have two cars, and they were both taking a curved path, and then they collide, and you want to know the angle of the collision, for example. So you get the path of the cars, and those two paths are curved, and the angle in which those paths meet, that's the angle of the collision, right?
Can this same strategy be done with getting longitude and latitude?
I'm not sure I can connect those two things the way you're asking.
Because when you're using the Earth, or I'm sorry, when you're getting the angles for longitude and latitude, I'm assuming one of those lines is one of those lines the Earth or not for longitude and latitude for the angle.
You gotta be more specific than that. I'm not understanding what you're picturing there.
Okay, how about celestial navigation? When you're measuring an angle in celestial navigation, and let's say instead of using straight lines, I want to use curved lines. Is there a way I can do that using in celestial navigation to get an angle?
How are you using curved lines exactly? What do they represent?
Well, that's the issue I have, is because every time we talk about it, it always goes into straight lines. Like
the 2 lines of sight. You're using 2 lines of sight, so.
But they're straight.
You have 2 rays. One points where you see the star, the other points where you see the horizon. You measure the angle between those 2 directions, right? That's what the sextant does. It's fine.
Okay.
You can
So
see
you
those
need
directions are straight. That's fine.
so a straight line to the horizon.
You're aiming at the horizon and you're aiming at the star. And you want to know the angle between those 2 aiming directions.
Okay. And you can't. So can this be done using curved lines?
For the lines of sight, you mean like if the light was curving in the path until it hit your sextant? Like if the
no. Like imagine the Earth was a globe for a second, and
already doing it.
No, but like just like imaginary, right? If let's say I wanted to get an angle, and I was standing on a sphere, and let's say I wanted one of those lines to be the Earth, right? So that would be one curved line.
That's not what we're doing navigation.
Okay, so you're not using the Earth. You're not using the Earth.
You're not using the Earth as a line for the angle measurement.
Oh, okay. That's good to know.
That's not the same thing as you're not using the Earth at all.
Oh wait, so you are using the Earth?
Yeah, you're aiming one of the lines at the horizon, right? The horizon is on the Earth. Point you're aiming at the horizon, that's on Earth.
Okay, and that line is straight or curved?
I'll go with straight.
Okay, so it's straight. And there's
the line between you and the horizon. You can consider that straight.
Okay, so using a straight line to the horizon. Why can't you just use a curved line for that?
Because the sextant gives you the angle between things you see, right? It doesn't give you the angle between where your feet are. Sextant doesn't know where you're standing on. It only tells you the angle between 2 things you're aiming at. So you aim at the horizon and you aim at the star.
Okay, so you need straight lines. Got it. You need the straight lines for the sextant.
Yeah.
Is there any way you can do this measurement with the star using a curved line with some other method besides the sextant?
Using the Earth's surface as part of the angle measurement?
I don't know. I mean, that's the only.
Sounds like that's what you're asking. That's not making a lot of sense to me.
Yeah, because it makes more sense if you have a straight line, but I was just wondering if there's a way to do it using curved lines.
I think I know an example to give you. So
yeah,
you want to get an elevation angle to the sun, for example.
Yeah.
So you put a stick on the ground, and then you measure the length of the shadow. So even if you're standing on a curved surface, you can still measure the length of the shadow. And if you know the length of the shadow.
Sorry, go ahead. Go ahead.
Alright, so the stick is orthogonal to the surface. The stick is like a normal vector, right? So it's perpendicular to the surface. And then you measure the length of the stick and the length of the shadow. From those 2 lengths, you can work out the angle to the sun. So one of those lines would be curved, which is where the stick is sticked.
So the shadow is a curve. I mean, sorry. The line that's curved is not the stick. It's the shadow, right?
Yeah. On a globe, that would be slightly curved, right?
Okay, so the shadow. Sorry, go ahead.
I just said you could still use that, even if it's slightly curved.
Okay, so the shadow is curved.
Mm-hmm.
Okay, now I see. Yeah, that's a better example. I like that one better.
Right.
That makes more sense to me.
Cool.
All right, I'm done.
Stuck on this triangle thing, though.
Zodiac,
I'm
are you not
done.
going to ask him how he has a flat baseline on a sphere?
Yeah, we don't use one.
I think I already gave an example. It's the line of sight to the horizon.
But that's not a. You said that's not using the Earth though. You said that's above the Earth, right?
No, one point of like that line is being established between 2 points. One point is your eye. The other point is where you see the horizon.
So you're not using the Earth.
But you need to do dip correction based on your observer's height. So you are actually that baseline is parallel with the Earth.
The baseline of your measurement is not.
How so?
Okay.
Because you're aiming at the horizon, which is below a horizontal line.
What?
What the fuck does that even mean?
It means that line is not parallel. Yeah, go ahead.
Which line is not parallel? Sorry, say again.
The baseline of the angle measurement. That's not parallel to the ground. Not even on flat Earth, it wouldn't be.
No, when you do your dip correction, it would be.
But then that's no longer the line you measured. That's the line you're calculating to, right?
Well, yeah, because the baseline is supposed to go to the GP of the star.
Yeah, that's where you make a mistake. No, it doesn't. It doesn't.
It doesn't.
That's not how it works. Hold on for a second, Bacon. They're still imagining a right triangle going from the observer's position to the GP to the star. And they're thinking that's a right triangle right there. It's not. You're misunderstanding everything if you think that's how celestial navigation works. Because the line going from the GP to the star and the line going from the observer's position to the star are parallel to each other. They do not form a triangle.
What?
Yes.
Sorry, you're going to have to show me that. I don't understand what you mean.
Okay, do you think there's a right angle triangle between the observer, the star, and the GP?
Yes.
Right. You know that doesn't match the rule of thumb used for the distance to the GP, right? 6 nautical miles per degree.
Sorry, how so?
A simple example, you have one observer has the star 30 degrees, 60 degrees above horizontal. So that's your first observer. Then you have a second observer sighting that same star. That observer now sees the star at 30 degrees above horizontal. So you go from 60 to 30. So from the GP to the first observer, that's a 30-degree angle drop. From the first observer to the second, it's another 30-degree angle drop. So using that 6 nautical miles per degree relationship, the second observer should be twice as far as the first one. But if you draw true right angle triangles, what happens is the second right angle triangles end up 3 times larger than the first one, not twice. So there's a huge discrepancy in the distance that you get from right angle triangles compared to you get from 6 nautical miles per degree, which is actually used in navigation.
Yeah, I'll need to have a look. I'm finding it hard to visualize. That's all. I'm not disagreeing with what you're saying.
No problem. I'll post a diagram. It will make it very easy. Just give me 1 second.
Thanks, Bacon.
Okay, found it. Let me just copy these. And paste in the chat. Okay, there it is. So you have the GP, you have observer A, observer B. GP, from the GP to observer A, there's 1 distance. From GP to observer B, there's 3 times that distance. And that's how you go from 60 degrees to 30 degrees if you're using right angle triangles. So that wouldn't match the 6 nautical miles per degree. In the 6 nautical miles per degree, the first 30 degrees of drop is the same difference in distance than the second 30 degrees of drop. So B should be twice as far from the GP compared to A, according to the 6 nautical miles per degree. Like if the star dropped a double, then he should be twice as far. But if you're using right angle triangles, that would put B 3 times as far, not twice. So there's a huge discrepancy between using right angle triangles and using 6 nautical miles per degree. 16 nautical miles. Am I saying
Yeah,
6?
I think I see what.
Right. So either the 60 nautical miles per degree is wrong, or there's no right angle triangle.
Just really quick, did anyone else have any other questions before we keep talking about the triangle measurement? Okay.
Well, I don't think so. There was a big silence in the room.
Okay. Never mind. Yeah, all right. Yeah, we can keep going down this triangle thing.
Well, I think the problem was laid down.
So when you're Okay, I like the shadow one. So the shadow being curved, that one I like is because you can demonstrate the shadow being curved, right? Like in reality.
Mhm.
Okay. And is there like a physical demonstration where you have the curved, like, of someone physically measuring the curved shadow using, like, I don't know. It doesn't have to be a protractor, but it could be some sextant or whatever, like using curved lines.
I don't know why you're focused on the curved lines, because the globe side isn't claiming we're using curved lines. The flat Earth side is also not claiming we use curved sides. So
you're not using. No, but earlier you guys said that you can get an angle between two curved lines. So I'm just asking, when you go out into the field, like in real life, not using the sextant, because we're not going to use the sextant because you said you need straight lines of sight. So, but you did mention that you have a shadow that was curved, right? So that would be like a real life demonstration. That's what I would like to see.
Demonstration of what?
Getting an angle from a curved line in real life. Like for example, if I go out, sorry, go ahead.
What about the laser beam and the spherical mirror? What about lenses? What about
a laser beam in a spherical mirror?
Yeah, when you hit the laser beam on a spherical mirror, it's going to reflect a specific angle, right?
Or parabolic antennas.
Okay, yeah. I want to see. Well, let's go one at a time. Which one do you want? Which one's easier for me to like replicate? Because I want to try it myself as well. I guess it doesn't matter. Let's just go with the laser one. So I just get a spherical mirror, point a laser, and then I have I have the laser shining, and there's a light that's being curved that's bouncing off the mirror. Is that right?
Yeah.
Okay, and then yeah, okay, and then what are you using to measure the physical, what are you using to measure the angle?
You can tell in which direction the laser beam is gonna be reflected towards by using the angle in which the beam is hitting the surface of the mirror, which is curved, right?
So you're not using a protractor. Okay. And what are you using? You're not using a protractor. What are you using?
You can measure the distance between the laser and the ball, and then they'll add where the laser then hits the wall where it reflects off of. You just make a triangle, measure the angles.
Oh, I see. So you're using okay. So when you have the triangle, let's say I drew out the triangle, right? Now, what do I use to measure the angles of the triangle?
Just look at the picture you posted in the chat.
Okay. All right. One second.
The red lines are you can imagine a third line to connect. The red triangle. The red lines are the two lines of the triangle that I'm talking about. Just imagine a third line connecting it back, right? You've got an angle there that he's labeled theta equals question mark. So that is an angle, is the point.
The angle depends on the angle that the beam hits the surface. So if the surface was curved in a different way, the theta angle would be different. So you can actually beforehand tell what the angle theta is going to be by figuring out what's the angle the laser beam hits the surface of the mirror.
Okay, and the laser is curving, right? The laser beam is curving?
No. The surface of the mirror is.
Okay. And the two lines of the angle that you're measuring are curved, right?
The forest beam before it reflects in the surface of the mirror. That's a line. There's an angle between the straight line and the curve. The beam is a straight line. The mirror is a curve.
The surface of the mirror is a curved line. Okay. Yes. Got it. Okay. And then how do you measure? Are you using you're not using a protractor to get the angle, right? So I'm assuming you can't
be great.
Can you just show me how about this? Do not show me a diagram. Just show me a person physically measuring the angle. I don't know if that makes sense. But can you just show me the person they have the spherical. Okay, imagine you have a human being and they're holding in their hands, they have a spherical mirror in their hands, right? And they have an angle, right, with the laser. And I want them to get the angle from that, measure the angle from that in real life, okay? Not in a diagram, but in real life. How do they, not using a protractor, how do they do it? Go ahead.
I think you're going too far with it. I'm not even sure what to look up. And I also don't see the relevance of any of this.
Well, I'm just asking, can you demonstrate it? I don't know. Is there a way to demonstrate physically measuring the angle from the spherical mirror without, because you're not just looking at the angle, right? You have to use something to get the angle, right?
We usually work the angle out. So we work out what the angle is by measuring other things. It's hard to measure the angle directly. So in the example of the spherical mirror.
So you're not directly measuring the angle itself.
No, the thing it'll be harder and unnecessary. So I don't think anyone would do that.
Why?
Example. It's just much harder. In this example of the spherical mirror, if you know the height of the laser beam, the distance to the spherical mirror.
Wait, why would it be harder though?
Because just practically physically measuring the angle in which a laser beam hits a surface mirror with a protractor sounds very unpractical. It's easier to know the dimensions of.
Go ahead.
It's easier to know the dimensions of the setup, like the diagram shows, and work out what the angle is. And you can test if your angle is correct because you can predict the angle theta. So if you worked out correctly what the angle is between the laser and the surface of the mirror, you're gonna get the correct angle theta, which is it's easier to measure.
The angle. You just backwards. You just reverse engineer it.
No, because you can predict theta. You can before turning on the laser beam. You can tell what theta is going to be by working out the angle between the laser beam and the mirror, which is curved.
Without measuring the angle, right? Physically. Like, you never actually physically measured the angle directly.
The way I'm describing, no. But you can test if you're
is okay. Let me ask you this: is there another example where you can actually directly, physically, in real life, measure an angle using at least one curved line, like in real life?
Sure. So you get a hula hoop and stick something straight into it, and you extend the line of the hula hoop where the other thing is stuck into it, and you measure the angle between those two lines. So you get a tangent of the hula hoop at a point of intersection, and measure the angle between the thing you stuck into the hula hoop and that tangent. That's going to give you the angle between the.
So, okay, so you have one line being the hula hoop, which is curved, and then you have the other line being the stick.
Sure. Yeah,
what?
You stick the stick into the hula hoop, right? And you want to know the angle.
Yeah.
So you extend the line of the hoop with the whatever other stick, maybe, if you want. So you pick another stick.
Yeah.
You get a tangent to the hula hoop.
Wait.
This is just getting too long.
You need a tangent? Why can't you just use the curved line of the hula hoop?
Because you can simply zoom into the hula hoop. As I said, the angle is because the angle is at the intersection. And you don't have a tiny protractor to measure just the intersection. So you have to extend it. That's why the tangent's for.
Wait, so you need to zoom in on the hula hoop?
Yes, or simply extend the tangent line.
So you need to zoom in on the hula hoop because what? You don't have a tiny protractor. Wait, why does the protractor say again why you need to zoom in again? One more time?
Because the angle is at the intersection. So
yeah.
The separation between the stick and the hula hoop, they change if you go away from the intersection. So if you try to measure with a big protractor, the separation between the stick and the hula hoop is going to be much larger because it's going to be much further from the intersection, and the hula hoop is going to curve away from it. And you don't want the hula hoop curving away from the original angle, which is at the intersection.
Wait, why don't you want it curving away?
Because the angle is at the intersection. So if it curves away and you measure to where it is far from the intersection, you're going to get a different angle.
Oh. So that would be like inaccurate?
Yes, the smaller your protractor, the more accurate you get. Or you can simply extend the tangent solves that problem because it doesn't rely on the rest of the hula hoop, only the piece of the intersection. So you simply extend the hula hoop on where it's intersecting the stick. You extend it with a tangent line. Then it don't.
Wait, but the tangent. Wait, but the tangent is straight though.
Yes. The tangent represents the slope of the hula hoop at the intersection. So whatever the angle is to the tangent is going to be the same as to the hula hoop.
Why can't you just not use the tangent and just use the hula hoop?
I think I just explained it.
So you have to. So okay. So if you zoom in, then you do not need the tangent if you zoom in, right?
Correct. Yeah.
Okay. How far would you need to zoom in?
Depends on how accurate you want to be.
Let's say, I don't know, 100% accurate. What would be 100% accuracy?
That would be physically impossible for any measurement.
Oh, you mean like in general?
Yes, no measurement is 100% accurate.
Oh.
There's always an error bar.
But isn't that a universal claim?
Yeah.
But how are you gonna test that?
Well, to get a 100% precise tool, you need that tool to be perfect, right? And
oh, I see what you mean.
We don't have a perfect tool right now, so we're gonna have to use the tools we have to build it. And if we use the tools we have to build it, we're gonna use imperfect tools to build it. So you also won't be perfect. Like you will never get a perfect tool unless you started started with one. So, for example, a ruler that reads down to millimeters cannot tell you with accuracy of nanometers. It can only tell you with accuracy of millimeters. So if something is bigger by a nanometer, you can't tell that with a ruler. So as far as a ruler can tell, those two objects are going to have the same size, even though they don't actually have the same size. But the ruler is not accurate enough to spot that difference. And that's true for every single measurement you're going to take in your life.
Okay, so the reason you believe that you'll never be able to get 100% accuracy is because there is no such thing as a perfect tool.
That's one easy way to demonstrate that that's the case, but I think that should be self-evident.
Okay, but have you tested all tools that have ever existed?
I think that's pretty self-evident. If you're arguing for perfect tools now, I don't think.
No. I'm not saying that it exists. I'm just asking. Like let me give you an example. If I claim that Santa Claus exists in every weather condition, in every country, in every location, in every altitude, that would be like a universal claim, right?
And
right?
If it's not self-evident to you, the tools have error. Every tool have error.
No, you're not listening. You're not listening.
I am. I'm just not interested in that.
Okay, if I told you that Santa Claus is real, and at every altitude, at any location, under all circumstances, at every country and continent and state and road and highway, that's a universal claim, right?
I'll ask you once and be honest. Are you
okay? You can't even answer the question. I didn't even finish the question. You didn't even answer it. You can't even answer the claim. You can't even answer. Oh my god.
So Zodiac, still there? What are you actually trying to do right now?
Is that Scott Mackey?
It is. What are you trying to do right now? Be honest, just for 10 seconds. 10 seconds. Tell me what you're trying to do right now.
I was about to finish. Is he still there?
I'm still.
Who's still there?
Okay. So back to what I was saying, right? So that's a universal claim. So in order for me to claim that, right, I would have to actually show you the evidence, right? So I would have to actually test my claim, right? It wouldn't make sense to claim what I'm about to claim without testing the claim. That would be crazy.
Scott's there.
I am here.
So I mentioned, I think yesterday, the software I wrote that does celestial navigation. I don't think I've showed you that, right?
Yeah, the celestial navigation stuff. No, you did not. I just saw the globe model thing that you with the.
Right, I'll post it in chat.
Which is really cool.
Yeah, well, that was just a diagram. This thing I just posted.
Yeah.
You can plug in. It's a bit old. I made this 2 years ago, 2 or 3 years ago.
I like how your circles are distorted to match their stretched out latitudes. That's neat.
Yeah, but you can click on 3D view there and see how the circles really are.
Wow.
Yeah, and you can actually change those parameters. So you can change the stars, the time, and try different readings.
Damn. You wrote all this?
Yeah. That is old.
There,
like,
is there some kind of engine or something you can borrow or utilize, or did you have to write all the math for this? And
I did. I wrote all the math from scratch there.
No way. For real?
Yeah.
Damn, dude. that is nothing short of impressive. Oh my goodness.
The current version, the current version of that website have HaverSign, which I didn't derive myself.
Mm-hmm.
But the first version of it, I didn't know about HaverSign, so I derived my own.
Oh, no way.
Yeah.
Yeah.
When I first heard about HaverSign, that website was already working.
Wow. This is amazing.
Thanks. That's why I can say for sure you need a globe. Because I did this from scratch, so there's no copy pasting math, there's no just following instructions, you know. It's literally, I started with the globe assumption and I got the math and it worked.
Unfortunately, I don't think people who've never programmed can understand how cool this is.
Well, I used this to beat MC Tunes challenge, the $100 one, not the 10,000 one.
What was that? I don't know MC. I don't follow MC Toon at all. So, what was his challenge?
He simply posted 3 star angles that he took with his phone and challenged like whoever to find where he was. So the first person to get it would get $100.
So is he up in Michigan then? Is this
that
his?
The one that looks like a tree?
Looks like a tree.
Yeah, to me that lake.
Oh no, it's not Michigan. I guess he's by Minnesota or something.
Let me see. I still have the readings somewhere here. I'm not sure if it's the same one in the webpage.
Yeah.
Get it. Okay, here it is.
How are you guys doing today?
I'm feeling kind of flat. How about you?
Yeah, it was in Minnesota.
Okay.
It is definitely not flat. It's a spheroid. And the specific type of spheroid I could tell you, but you'd have to give me 2 seconds. I'm high, but not stupid.
Why? Wait. It's a spheroid?
Definitely.
Did you see where do you see it?
From fucking space.
Hell yeah, bro. Wait, I got one problem. I got one problem with that. Okay. Is this space in 10 to the negative 17 torr open vacuum?
What the hell is that?
Yes, it is.
Because
I
if
know
it
base
is,
12 math, and you're not gonna spout some random numbers at me and then say,
okay, how about just like it's a area that has low pressure, let's say. Like no air. Do you agree? How about this? You can't breathe in space. You agree with
you know
me
what
there?
else? If you hold your breath, you also can't breathe.
Facts, bro. Facts.
I feel like that's the type of logic we're talking about here. It's illogical fallacies that people are speaking in.
I didn't even get to the argument, but I was just asking you how about this? Define outer space. What is outer space?
Can you define outer space?
10 to the negative 17 torr open vacuum.
All right, how about if I define outer space as the space that I'm not in?
I guess I'm in outer space.
That's
I feel like
hilarious.
I'm in outer space. I'm on Mars since 420. I've been on like edibles ever since. And
What? Your mic cut out.
oh, I've been on edibles ever since 420.
Oh, I thought you said yeah. I thought you said that, and then I thought you said and. I thought you said the word and after that. I don't know why.
Oh, and hitting this pin, and then I hit my pin.
Yeah. Yeah, that's
I think Zodiac has been too.
No, I don't do drugs.
Really?
Yeah.
You should. If you believe that there's a flat
No,
Earth,
because
at that point,
they cost money, bro. They cost money.
You're like this without drugs? Wow.
Don't you want to save money though? Like, I don't know. I'd rather not waste money on that.
So what do you waste your money on?
Food.
I buy a lot of food too. I just make enough money that I can spend it on everything that I want. You know what I mean?
Food and
OnlyFans.
No.
You do
Honestly,
a
I
little
don't
bit of
even know
crack
why
every
people.
once in a while.
He doesn't sound like an OnlyFans guy.
Do people actually pay for? Okay, this is a serious question. Do you guys know anyone in real life who genuinely pays for something that they can just get for free? Like, come on. There's no logical reason why you would do
I
it.
mean, I pay for something I don't get for I can get for free.
Like what?
I get a massage, from a massage therapist for like 5 hours. It's fucking nice.
Also, it's not that simple because these guys that pay for OnlyFans actually also get the opportunity to message these people and build a connection.
Oh, I see. So it's like a psychological
virtual connection.
Okay.
Yeah.
Yeah, it's fair. Yeah, that actually no, that's a good point. Yeah. I just couldn't imagine. Sorry, go ahead.
I was just saying, it's actually really sad.
Yeah, I just couldn't imagine like, oh man. You know what it is? Okay, you know what it is? maybe I just haven't reached that level of desperation. I have not yet experienced that level of deprivation or being deprived on that level. So
They can't get bitches.
It's
what
like
if they went to the gym though?
there's actually been studies done, and they the problem is that like it's both sides. There's lack of accountability on the incels, but also like the females like don't even look at them like as like they don't give them the time of day, right? They're like ghosts.
They just look
So
at money.
how would you feel if no female gave you any attention?
But don't they still have their moms?
Well, that's different.
Yeah, it's different, I guess.
No, not really. It's still a motherly's attention, and there's a lot of reasons why scientific studies have been done on that.
Yeah.
People need
Yeah,
their
but that's
mommies and
different from romantic
Yeah.
fulfillment. Like it's
Yeah.
like
well, like if
mom
you don't
is.
have your mommy, you're gonna have mommy issues, and you don't have your daddy, you're gonna have daddy
Let-
issues, and then
Let me
that
illustrate it like
figures
this,
out.
though. If a 10 out of 10, in your opinion, or sorry, if your mom told you you are the most handsome boy in the world and the smartest little boy ever, and then you'd be like, okay, she's just, that's the trope, right? But then if a 10 out of 10 that you don't know said that to you, it obviously carries more weight.
Yeah, because one is more or potentially more objective, I guess.
One's unconditional, one's conditional.
Oh yeah.
Like it depends on like what's happening. I mean, like if a 10 out of 10 says you look good while she's sucking your dick, is that objective or is that like just what's happening?
I mean, she doesn't even just say it at that point because it's already speaking for itself.
Or do you just have a big dick?
You know what's weird though? It not only would I have to reach that level of not depravity, desperation. Not only would I have to reach extreme desperation, I would also at the same time have to not be broke. In other words, I would have to have money at the same time. So it's kind of a weird situation.
I hate when people think money matters.
To get to buy I'm talking about in the context of paying strangers who are women.
I mean, like, do you want money? I'll give you money.
No, I'm at what the fuck is this? No, I'm explaining something.
I mean,
in the
if you're
context.
just giving out cash, yeah, I'll give you my PayPal.
Why don't you?
Okay,
why
give
don't
him
you
his
buy him
cash
like a
app.
month? Buy him a month and like
No,
Zodiac.
yeah,
that's
let's do an
degenerate.
experiment.
That's
Don't
degenerate.
you like doing experiments here?
I'm gonna buy her a month of church. I'm gonna buy her a preacher, and she's gonna go to church, and we're gonna turn her back to God. We're gonna turn her
Maybe
away
let's
from
do it.
sin.
So you buy the
She's
month,
gonna
and then you buy her the preacher.
Okay, she's gonna
But no
go. She's
sex
gonna
with the
turn
preacher.
away from sin. She's gonna turn away from the devil and turn away from sin and sodomy, and
Oh,
she's gonna
God.
turn towards God.
That sounds boring.
And that way, she won't be turned to sulfur and then Sodom and Gomorrah. That's
Who
what happened.
believes in hell is boring. Like you didn't read enough of the Bible. Or know enough about human anatomy to know what happens when you die.
What does happen? Is it just like nothingness?
A certain chemical is released, you know.
Oh, sorry. I thought you meant like. Well, let me ask you a different question. Do you believe that there is an afterlife, or do you think that once you're dead, it's over and it's just black nothingness, which is kind of a relief, to be honest. But
You would fucking hope it would be not be
Oh.
black nothingness. That would be boring.
Wait a second. Why do you think that's a relief?
it's a relief because then you don't have to face the consequences of your actions.
I think you just had I think
You're gonna face the consequences of your actions.
Yeah.
There's no getting around that.
Yeah, but that's see, that's the thing. Like, I believe in karma, so I mean, I think it's
I mean,
inevitable.
I believe in karma, I believe in chakras, I believe in heaven, but I don't believe in hell. and I believe there's other afterlives, but I would probably
Wait,
like to
why
go
don't
to
you
heaven.
believe in hell though?
Because your
I
hell is
believe,
your karma, and it could be here.
Well,
yeah,
it's just what we were
what you
talking
do.
about. He doesn't
Just
want to
get
be
back.
accountable for his
No,
evil
I will
deeds.
have my
No,
own.
that
I
was
will
me though.
personal hell whenever I die because of my actions.
Wait, what?
I will have my own personal hell before I die because of my own actions, and then I will eventually be able to go to heaven. But I'm gonna have to go through my own fucking living hell.
I thought you said you don't believe in. Oh, you mean like an afterlife and hell? That's what you meant.
No, I mean like whenever I die, a chemical is released like DMT, right?
Yeah, isn't that what Joe Rogan does?
Yeah.
A lot of people do stuff like that. A
Sorry.
chemical like DMT is released, and
Yeah.
the bad things that I did in life, I'm gonna have to go through in a certain way that's gonna be like hell, ain't it?
Oh, I saw a movie like this. It was a Korean movie where it was interesting. I don't believe in it, but it was basically once you get to hell, you have to. There's different stages you have to progress through to basically plead your case or redeem yourself to make it to heaven. And yeah, it's really interesting.
Yeah, I'm Buddhist as well, so that makes a little bit of sense with what I believe in.
Wait, so do you believe that where you're gonna get reincarnated?
Well, it depends on what you did.
I thought you also said you went to heaven though. I mean, you're gonna go to heaven though.
I hope so. Don't you?
But you know what's weird to me?
Just because you go to heaven doesn't mean you don't get kicked back down here.
Oh yeah, that's true. I have a question though? Does heaven have gates? I know it's kind of a weird question, but
have you read about heaven at all? Like just any
no,
type
no,
of
no, no, no.
like I've read a lot of religious books, just more about like all types of heaven and all types of afterlife.
Does it have gates like borders?
I'm not
Yeah,
sure if you could even
it
really
talks
Like a
about
wall?
I'm not sure if you can
Yeah.
conceptualize it visually.
Okay. The only reason I'm asking if
I
it
think
has gates,
Trump built the gates.
yeah, and Mexico paid for it. No, but
They
like
better.
I was one true. I was. I can't even ask my question. It's too funny.
Ask it.
Oh my god.
It better be funny. It better be funny now.
No, but that was no. It was okay. My question is, if heaven has gates, hypothetically speaking, then that means someone is either trying to be kept in. In other words, they're trying to keep something or someone inside, or they're trying to stop someone else or something else from
Have you
getting
read
in.
the Bible? It said that
Not funny.
getting into
That wasn't
heaven
a joke.
for a
It
rich
was.
man
I was
is
just
like getting
laughing
into
about
heaven
this other thing.
is like finding getting a needle through a fuck. I'm high.
So that's
Something
why
with a needle.
this is why I say you can't conceptualize it because it's like you can't take everything too literally. Like for example, when like the angels rebelled, right? That became demons, and God there was a battle, right? It's not the battle that we think of. It's simply just God saying, "Get down there. You're not up here anymore." So it's like it's same with like the gate. It's not like it's more symbolic. It's not like actually like demons
like a
can't come up and
metaphor.
like demons can't come up and battle at the gates with angels. Like that's silly.
That would be cool though.
It would, but you know.
It's just not meant. It just wasn't the vibe.
Even angels, as most people think of them, I just discovered this recently. So angels, as we think of them in the human form from the movies, it's actually not how they look. They actually, if you look up the true form of them, they look really scary and really like just it's insane.
Angels?
Yeah, look up angels in their form or something on Google, and you'll see like
I don't know. Archangel Michael is pretty hot.
A biblical description of angels. I saw a TikTok on that, and they look like a bunch of weird eyes and shit.
Yeah.
Oh yeah, I saw that today. Somebody posted it in the other one. Yeah.
Not to say they can't come in human form, like they did with like Sodom and Gomorrah to warn that one family, right? But when the people of the city tried to have sex with the angels because they're so beautiful or whatever, but their true form is not human. Look like.
That's a bummer.
Yeah,
I'm just kidding. It's not.
They're shapeshifters. Shapeshifters.
Yeah.
Hey, do we? What do you guys think about Atlantis?
It was a cool movie. It was a good movie.
I came. My ancestors are Atlantean.
Like from Georgia or the actual underwater city or whatever.
Atlantis.
Oh, okay.
Didn't they recently find Atlantis?
Where was it? Where?
I don't know, but I just remember seeing something pop up on my feed of a bunch of pictures underwater of like a fucking city that seemed like Atlantis.
I saw a movie in Disney about it, and it was about these people wearing white. They had like white face how would you say it? Face paint, white face paint, and they had like futuristic. I don't know. It was a cool movie.
Yeah. Well, what's really interesting is like there's like this one I went down with the rabbit hole of the land of Tartaria, which used to be on maps, and it's like where'd that go?
Yeah, and the pyramids as well.
It's still happening. You know, the world fairs are still happening, right?
Tartaria, and another one is like who built? I mean, the pyramids, right? I heard that's like a whole nother rabbit hole. Is like,
oh yeah.
What do you guys think of the people that just say, "Well, the Egyptians built it"? What do you guys
probably fucking did?
Okay,
they had
face.
slaves, didn't they?
They're hiding. No, they're not. They know what really happened. They're just giving us that narrative.
No, someone taught them a certain type of math, right?
Yeah. Where is Tartaria located, though?
Tartaria?
Is it like in every continent, or is it just in one like place?
Jesus learned from the Egyptians, so.
The most interesting point about the pyramids is that they like I watched a video, but they are like perfectly aligned at the center, like some coordinates that align with something else.
Yeah, they didn't make a higher energy thingy. It's like they make a certain type of hertz or something like that when you sit in the middle.
Wait,
it's all about
the sound?
It's all about energy and sound with them. They knew a lot about spiritual stuff that most people forget.
When you sit in the middle of the when you say in the middle, are you talking about like inside or like just between each pyramid or what?
No, inside in a specific chamber.
Oh. So if you go inside the pyramid, and you measure the sound, that's cool. I didn't know that.
How do you know that?
I don't. I just
the other guy. How'd the other guy know it? Did you measure the sound?
I've measured everything. I've been kicked out of places.
Really?
Yeah.
Did you get charged with anything like trespassing or anything?
They tried, but I kicked their ass.
Hell yeah. Batman.
God.
I believe you. Don't worry. I'm on your side. I believe you.
The children are taking over the room.
100%.
You know who actually trespassed the pyramids was Vitaly. He's a YouTuber. He actually has it on video.
I actually did send a drone and a couple of different things.
But anyways, so Tartaria, was there any specific continent that you guys think Tartaria is on? I don't know who talked
everywhere.
I don't remember. It was in some area on the. I don't remember where though.
They're in your walls. What do you mean?
You know what's weird about Atlantis though is because I don't know why, but I just remember this game called BioShock where there's like an underwater city and
BioShock is so fun to play.
Yeah. But I don't know if it has anything to do with Atlantis, but I just know it's like an underwater city. It's pretty dope. At least like the
I haven't
first two
played
games.
BioShock in years.
Yeah.
Jesus, that brought back memories.
So what were you guys talking about before the how do you make a
The OnlyFans thing?
No. How do you make a
Triangle angle?
with two curved lines?
Yeah.
Yeah, food food's my buddy from the server. He's pretty smart. Ask him. What was the other
How
thing?
about you take your hands and then make an angle?
No, but that's straight. They're talking about curved.
You can do that with your hands again.
Yeah,
Your
he
hands
tried
can
to
be curved.
You guys can figure that out.
he gave me an example. He gave me a bunch of examples. One was like a shadow that was curved. Another one was like
Blood splatter.
There was a bunch of them. I can't remember them all, but yeah, there was a few.
Laser.
Oh yeah, the laser and the spherical mirror and the laser.
Sun
Oh no,
rays.
it was sorry, I remember now. It was a hula hoop and a stick, and then you zoom in on the hula hoop. That's what he said. He said you zoom in on the hula hoop.
radius of pi.
Yeah.
Like circle math.
And you need he said you need a really tiny protractor. That's what he said. Because otherwise it's inaccurate because you
got to get down to the points, like the
intersection.
At that point, you might as well just switch to base 12 math. That'll make it easier.
Yeah, so I guess where you take the angle from, that is interesting though, because even if you took two straight lines and you just took the angle from like further out, I guess it would also you'd run into the same problem actually. But I guess I'm just so used to using straight lines that I never really thought about it.
Well, a straight line really doesn't exist. Like you can say a straight line, but straight lines don't exist.
I agree. The Earth it's pretty bumpy. It's not like it's a bumpy sometimes well, actually there is one exception.
Have you ever been in a cave?
On a cave? No.
No, in a cave.
Oh, in a cave? I don't remember. Honestly, I don't remember. I don't know.
You ever been in a jet?
In a jet? Like an airplane?
My family owns jets. I've been in a jet. I've been very high up. I've seen the curvature.
Oh, you saw the curvature from an airplane?
From a jet.
I call cap.
Do you
send pictures? My grandpa owns a company. My dad's brother owns a law company. I don't really talk about.
Do you
stuff like
remember?
this.
Do you remember where you were flying from? I just want to in case I ever try to see it from there.
I was going to Alaska.
Okay. And you were in an airplane. You looked out the window. You saw Earth curvature.
Oh, I went to go see the aurora, but it was really weird because I was over the ocean and you can kind of see like a really weird curvature when he went way too high up because fucking air he's my brother's an asshole.
Okay. But just to be clear, you were in an airplane. You were flying towards Alaska. You looked out the window and you saw the Earth being curved, right?
Yeah, so
you can't really see the curvature of the Earth out of like an airplane. I mean, I don't think the Earth's flat. I think that's like retarded. But
I didn't say an airplane. I said a jet.
He thinks it's okay. Sorry, go ahead. Sorry.
But you can't really see the Earth's curvature out of like an airplane window. But
I might have just been on shrooms then. I think.
What? Do they even allow you to get through TSA?
Hold on. I just found the fact so the other guy was wrong. For the pyramids, the exact coordinates of the Great Pyramids of Giza are the exact same numbers as the speed of light.
Who the fuck cares? What? That's schizophrenic, dude. What are you talking about?
No, it's true.
What about the speed of light?
The location of the pyramids is it's the same as the speed of light numbers.
Cool.
It's very interesting.
That is cool.
What's your conclusion?
I don't know.
Well, it's not the same. Egyptians were pretty based.
Was it speed of light 2 minus? And
dude, someone said something about TSA, but it's a private jet.
Yeah, how'd you get the shrooms on the past the TSA? Oh, you said private jet. Okay, that's it.
I put them in my Miralax bottle.
Got it.
But TSA, I don't like TSA. They don't like me either, really. I'm on a lot of lists, I think.
TSA.
The government doesn't like people that know magic. Or how to make a nuke.
Do you believe the moon landings were real?
Hell no. Hell no.
Yeah, I didn't think so. I mean,
like,
what do you think?
There's a possibility that they were real, but I think like maybe the.
What do you think aliens are?
Wait. Let him answer first. Go ahead.
I think there's a huge possibility that like the effects, and like this has been studied, like the effects of like radiation on like film, and like the film that they were using back then that they would like film the moon landing with. I think there may be a possibility that like it got so corrupted that they couldn't use the film to prove that they went there, so they like staged a recreation of it. But I think there's so many people that were involved in that would have to have been like sworn to secrecy and lying.
What about the
Well, it was compartmentalized, right? And a lot of people were switched around a lot. So there's few people that knew the big picture. But furthermore, if you really aren't convinced, you should watch the video "Astronauts Gone Wild," where a journalist confronts pretty much every astronaut that's alive with leaked footage from NASA of them faking how far they were from Earth in their ship. And Buzz Aldrin pretty much says, without saying, that they didn't go to the moon twice when he's confronted.
Buzz Aldrin like punches people in the face when they confront him about that stuff, man.
That was the reporter, actually. That Bindu. And when he's getting pressed about it, you'll see in the video, Buzz concedes twice, where he goes, "Listen, man, you're barking up the wrong tree. You should be talking to NASA, not me." And he also says, he goes, listen, man, we were just passengers on a ship or some shit, right? Like, he pretty much said it without saying it.
But I mean, that's kind of what they were. I mean, they were launched in like a tin can in this,
in a container, right? Yeah.
I'm like, I don't know, man. I that's one of those conspiracies that I understand like skepticism on, but
allegedly launched in a tin can. Well, you can say it like that.
But I mean, there was like those people on Apollo 1 that were like killed. There was like so many
right.
Fatalities in like the attempt to do it, and like there's totally the incentive there to fake it because it was like the Cold War with the Soviets and whatnot. But
and also with Apollo 1 though, hold on, Apollo 1, that's a good point you brought up, because those were basically those were the astronauts that were like supposedly were going to be like the Buzz Aldrin and the team that went to the moon, right? They were like the stars of NASA. But the problem was that Gus Grissom, which one of the astronauts in that group, was very vocal about how NASA's shortcomings, and even hung a lemon outside of a press conference to like mock NASA. And basically, if you listen to the video of before they died, there's actually a recording of it with them in the testing module. Even Gus Grissom even jokes then when they're having radio frequency problems. He's talking to his fellow astronauts and he goes, "We're supposed to go to the moon, but yet we can't talk between a few buildings." And they all start laughing. And then a couple minutes later, the accident happens and they all get burned alive. And then the guy who investigated Apollo 1, him and his family died shortly after investigating, and he was very critical of all the shortcomings. And him and his family were killed on a train track, hit by a train or some shit.
Oh damn!
They were hit by a train on a train track while in a train.
I think the tragedy, like all of the. Whenever I feel like when you report on deaths, it creates almost like a it almost is like traumatic to hear about it, and that's why everyone is completely silent on it, because if as soon as you start mentioning it, it's like, oh, now this is gonna just turn into like, it's just gonna be traumatic. So
I think the moon landing thing is one of those conspiracies that I don't think will ever be provable until like a private company like SpaceX goes to the moon and like shows that the flag is there, right? Or the footprints are there. I don't think you can ever prove that. The ones for me that like.
Have you looked at the SpaceX, like the CGI they use in their YouTube videos? That shit's funny.
Yeah, I mean, I'm not. I think Elon Musk is like an egomaniac. And
you know what Elon Musk said? He said it looks so real. Or what does he say? It looks so real because it's so fake. Or no, it must be real because it looks so fake. Something like that.
When I think William Shatner went up on Jeff Bezos's kind of like space thing where like they kind of orbit the atmosphere a little bit. And have you guys seen that video where like he's trying to like talk to Jeff Bezos, and like Jeff Bezos is like cracking champagne and like not even listening to what William Shatner's saying?
Was this like inside of a rocket, or was this like in like
I mean, like pretty much, yeah. It was like this kind of like rocket thing that went up in. But what William Shatner said, I mean, he was on a show, like the most famous show about like science fiction, like space travel, and he kind of talked about how he'd always thought about what that would be like and how it would be so amazing to be like in the cosmos. And like what he said was that like it just made him like profoundly like depressed because you get out there and it's just black darkness. And you see the Earth, and it makes you realize how special what we have on Earth is. And there's a thing that like astronauts get called like the overlook syndrome or something like that, where you kind of just get like this state of the like geopolitical issues on Earth and whatever, and like just not being able to like kind of associate with any of them because it's like we're so small in like the grand picture of things. It's like the fact that we have like infighting on our own planet is like pretty insane.
Yeah, I think so they can't really. You can never really appreciate it until you see from a different perspective. That might be another way to describe what you're saying. Really?
Yeah, I mean, I think that there's parts of our own planet that we have like we know more about like our solar system than we do about our own oceans, right? So it's
yeah, the oceans. The oceans not only would be able to hide like little islands. The oceans are so big that I would not be surprised if they're like hiding not hiding, but like if there's like undiscovered huge chunks of land,
Oh, that's probably what's up in Antarctica, honestly.
It could be anywhere.
I think in the ocean, man, there's so many species, like specifically in the areas like around like the Marianas Trench, that we don't know about, and like there's like theoretically species that like have not been affected by evolution the same way, so they're kind of in the same state as they were in like the prehistoric era, where they're like massive, and that's why like the giant squid theoretically it, like still exists.
Because there's so much water. There's like millions of gallons of water. Just like holy shit, trillions.
Yeah, I mean,
have you guys seen the cameras that have gone deep in those parts and seen what the fucking fish look like? They look like monsters.
That's it. They look like aliens. Literally, they look like stuff not from like this planet. And the deepest parts that we've gotten to with cameras and stuff, it's not even close to like how deep it can get.
Yeah.
It's just crazy, man. And it's like you see some life that like life in the ocean that just never evolved and has been the same since like prehistoric eras. And it's just crazy to look at, man.
Yeah, different world. Yeah, it's a different world.
It's
there's
really
some animals you can look at, like you
So
can
what's
look
the
at like
hypotheses on that? What's the hypotheses on that?
what do you mean?
What hypothesis?
There's
It's
no
not science.
hypotheses. What the fuck you talking?
There's got to be a hypothesis on that.
What do you mean for evolution? Evolution's fake.
No, for the sea animals to just like have never evolved and be so prehistoric and everything.
Oh.
Well, because they've lived in an environment that there's been no need for adaptation and like evolution.
Yeah, it almost brings.
She's not skeptical.
It also is interesting. Like it brings perspective to the stories of the sailors in the past that saw weird shit in the ocean.
So then there could be mermaids down there.
Facts.
No,
let's go under the sea, bro. Let's go.
Well, you just got to be, put on a little sailor outfit and kind of,
I mean,
dude, you're
take
playing
your boat out
like
there.
Saturday morning cartoons in your head,
besides
SpongeBob is real.
Besides the mermaids, like there's that one video on YouTube of the fighter pilots recounting their story of seeing a UFO mimicking them underwater, and then when they were like, and they were told by their commander to go to a different coordinates. And before they got there, the UFO took off and got there before them. It's wild.
There's all those like declassified videos that they released of like these like kind of like tic tac shaped like crafts that they move in patterns that like completely like defies like the laws of aviation like as we know it.
Just think about it. A UFO underwater mimicking the speed and the exact direction of a fighter pilot, of a fighter jet.
Well,
yeah,
really?
no, I think the Pentagon like declassified a bunch of videos of this shit happening. It had been known for a while, and it's like I don't know. It's like if they're just now declassifying that. I think there's so much more that like they know about.
There's even lawsuits right now that a lot of people don't know about, where basically like it's very common that these UFOs appear also near nuclear bases, and there's lawsuits because basically what happens is when they land, servicemen approach it and they die instantly, and so those families are suing, and this is like literally going on right now.
Sad.
That's really from the radiation. That.
Where did they? Do you have any? Do you have any names? I kind of
for what I just talked about.
Like when you're talking about the lawsuits, like, are you talking like there's I'm assuming there's the families. Should we get into this?
They aren't.
Yeah,
They aren't
sure,
really.
let's get
They
into
aren't.
it. Make it
They aren't
good.
necessary. So the military judicial system is separate from the public, right? And I heard about this from a reporter, Tucker Carlson. He was talking on a podcast where he's well connected with all
I
those
remember.
types of people, and he said, and he was telling the interviewer, he was saying, he's like, I have someone that's in the military that told me about this. That's definitely reputable.
Dude, Tucker Carlson's a fucking loser.
Does Tucker Carlson ever talk about like Israel? Or, I'm sorry, not Israel.
He's super pro-Israel.
What's the word? Oh, he is.
No,
Okay.
no, he's not at all.
Tucker Carlson? Are you joking?
Dude, he's literally in a battle right now with Ben Shapiro over us sending Americans over there.
Well, yeah, I mean, of course that, but no, he's very much like pro keeping the American kind of representative in the Middle East.
Isn't he? Yeah, he's more like mainstream, right? So he's got to be owned. I'm assuming.
He's funny to me, man. He's one of the like Fox News kind of like goofy fucking like for like 8-year-olds to watch, and like every segment that he does, it's like
I just don't think you're representing.
This is Tucker Carlson right here. When I was a kid, boys peed standing up. Now you have boys peeing sitting down. Don't believe me? Take a look.
Listen. He's definitely not pro-Israel because also just last week he released an interview with a Palestinian Christian pastor that was condemning the atrocities that Israel's bombing also Christians in Palestine, and Israel got super butthurt about that being released.
Yeah, I mean, well, like Hasidic Jews in Israel, like fucking spit on Christians and shit. Like they're fucking pieces. Like they're fucking assholes.
They deface graves.
Sorry.
They do. They hate Christians.
Yeah,
Tucker... Sorry, go ahead.
No, it's the reason a lot of like Christians support Israel. And this is like almost ties into like why so much like U.S. tax money goes to Israel is because there's a lot of like evangelical Christians in like Senate positions. Is that they believe that like for the rapture to happen, for like biblical prophecy to happen, is that the Jews and the Muslims need to go into a holy war. So it's like they're like hedging their bets on like we should. Support it.
There's literally a video of Netanyahu back in the 90s talking to like the most prominent rabbi in Israel, right? And on camera, on audio, the rabbi is telling Netanyahu to bring forth the Messiah, to like speed it up. And Netanyahu's like, we're working on it. Like, so that's why you see like this reckless action by Israel and like bombing Iran. They're trying to fulfill the prophecies artificially.
I mean, Iran bombed them. But
but then the missiles got shot down, and it's kind of like, all right, let's let it end. But no, they're doubling down and going back again, right? It's like they're really provoking a Middle East war.
Bro, I don't even fuck with Israel, but I'm trying to get me some Iron Dome.
Yeah.
Discord is so quiet at the moment, apart from fucking CB having his own fucking rant about fucking women at the moment. But wow, hi guys, hope everyone's well. We're still in seek of this curve, or has everyone given up? Gone home, gone back to reality? Whoops, there goes gravity. Z's in the house. facto, Tom. Can you explain gravity to me, dude? It seems to be pulling me down. I'm not sure how to deal with it. Really time to find my own resonance, guys. So enjoy. I'm going to piss off. Go find someone else to fuck around with. So enjoy your afternoon, guys.
Hey. Is anybody in here?